That Michael Mulholland. It's Michael Mulholland that's going to present the web-based Propeller 1 compiler.
Okay, we'll see when he gets in. Okay, welcome everyone to the Propeller Live Forum, April 9, 2025. Kenny's out. Maybe Chip will explain what he's doing right now at American River College. And just as a reminder, you have all the recordings for these events at the Parallax YouTube channel. And if you have any topics or any questions for today that you would like to ask, just send me in the chat and I'm going to add you to the list. Today we were preparing a Micheal presentation talking about the web-based Propeller 1 compiler. And Chip and Stephen, I think they will share the Peanut TS update today. One thing I wanted to mention before getting started is we are talking with different suppliers of Parallax regarding effects of price increases due to the current tariffs. So right now, all the suppliers is very uncertain. Our price, our costs, we manufacture in Rocklin, California, but the cost of our components is kind of uncertain. So at this point, we are not increasing prices. But we know prices are going to increase. So for now, you can order at the existing price. We cannot run any sale. But if you want to order material at this price, we will honor those sales. And prices will probably increase. We are thinking about next week. So if you want to take advantage of the current prices, you can do soon. Also a reminder, we have coming soon, the May Propeller Developer Day and the Open House. Not sure how many people in the community are going to be going in person to Parallax. If you are coming and you did not register, please make sure to register so we know you are coming. And I have some notes from Ken that we have some presentations aligned. Francesco, talking about the robot base. Doug Pinta will be showing in person. Some will be live. Francesco will be live from Italy. Doug Pinta will be in person in the building at 11. So if you want to present or if you want a table to show and share what you have made with the Propeller, just let us know. Email Ken or send a message to me, and we will add you to the list. Also, I did not do this graphic. That was Ken. I'm going to be there in person too. I'm usually from Spokane, Washington, but I'm going to be there, and I will have a minivan. So if you need any help with, pick up at the airport, drop off, I'm going to be there from Wednesday through Sunday morning when I actually have to go myself to the airport and check in and let the minivan go. So if you need any arrangements or help with your stay at Parallax, let me know, and I will help as much as I can. So now I will hand it over. Let's see if Micheal is here.
I don't see him yet.
So then we skip ahead to Chip. What do you want to do your part of the presentation with Stephen?
Yeah, are you up for that, Stephen?
I don't know that we have a whole lot to say yet. I wasn't expecting any presentation, just a casual mention. Jeez.
Well, go ahead and say something about what we've been working on, if you would.
Okay. When we first implemented the TypeScript compiler, the version of Peanut TS, as you may know it, it was implemented at version 43. Since then, Chip has been very prolific, and we have lots of versions since then. We're at 51A right now, and so it's continuing. We've taken the past 20 days, 25 days or so, and we've upgraded the compiler. We've added all the new functionality through 51A. We are now at the point where it's implemented, and we are upgrading the regression tests. I don't know if you know, but this version has full regression testing for the language features, which is turning out to be a benefit for both Peanut TS and Peanut, because as we write regression code, we are also checking to see that the Peanut behaves as advertised, And as we've been doing this, it's every couple of days, Chip will remind himself that there's something better he can do in code or find something and fix. And so it's serving well for both of us to improve the stability of the two compilers. And so that's exciting to see. We're probably about a week and a half, 2 weeks out from release of 51A for Peanut TS. This is a command line compiler only. It runs on all platforms. And I'll have distribution packages you can download for each of your platforms. So if you're on a Raspberry Pi, you've got a full compiler just like FlexProp. If you're on a Windows machine or if you're on a Mac, full compiler. It also is integrated like FlexProp and with Load P2 and things like this. It's integrated with Visual Studio, VSC, Visual Studio Code. And so you can do keystroke sequence builds and downloads and stuff like this to run. And that's where we are with that today. Chip, did I miss anything?
No, that sounds pretty good. And there's some other stuff you're working on to replicate a lot of the debug, but should we talk about that at all?
Not yet.
Okay.
We have a goal to make that happen eventually.
Right. Okay. I don't want to overload you.
Right. Now, Maka is also building that into his tool suite. We did a little research to see if we can share, and our implementations are radically different. So there's not a lot of opportunity for sharing between the two of us, and that's unfortunate, but it also means we'll have 2 open source implementations for the client side. That's also really important. That's 3, including Peanut and Propeller Tool, and Peanut, Propeller Tool, and Serial Terminal. And so a lot of implementations to choose from and code to view how the whole thing's working and things like this. So good for the community that we have lots of copies of things.
Good. Okay. Yes. I just messaged Michael Mulholland. I talked to him a little bit before the meeting, and he was getting something ready. He may not be totally ready at the moment. That's why he's probably stressing out. Anyway, we should hear from him. Yeah. Oh, he says 5 minutes away. Okay, he's got 5 minutes. So
typical presentation woes, huh?
Yes.
So, any questions? Any questions about the event? Anybody in the forum that is actually coming to the event in May at Parallax in person?
Well, right now it doesn't seem likely that I'll come. Huh?
I'm hoping
Oh.
to.
Well, Ken didn't get back to me really, and also apparently there's just detaining people at the borders based on like vibe checks now.
Jeez.
On what checks?
Like they just like, yeah, that guy looks like a terrorist. Let's put him in jail.
Oh, I don't know. I don't know if it's like quite like that, but I don't know what it is like though. On the other hand,
I don't know. They apparently just detaining like random people. It's really funny. And by funny, I mean kind of horrifying. You don't want to get involved with that.
yeah.
So, John Huffman, are you coming? Are you set for a table? You have something to show? Are you going to connect one of those cameras inside Parallax to do some air takes or something? Oh, you are muted. Let me see, John Huffman.
Oh yeah, there he goes.
Yeah, I'm gonna have a table. John McPhail's gonna have a table next to me. They're gonna bring their some of their projects, and including the laser tag, some of the laser tag gear to show. And I'm gonna have some of my products to show, and I'm working on a couple of little just personal projects that I'm gonna bring and show at my table.
I'm going to check to make sure on the document that we have you there.
There's Michael.
Hey there.
Hey.
Hey, Stephen.
Does anyone else plan to come?
Francis,
Are you nodding yes? Okay. The other Bauer, maybe?
I'm trying.
Okay, well, you're all welcome. We'd love to see any and all of you.
so Francis, do you need a table? Last month I kind of
If you have a
suggested.
table, I'll take it. One
Okay.
question, is there going to be AC power at the table, or we need to be
Of course,
portable?
yeah. We can have as many tables as needed, and yeah, we'll have extension cords, whatever. It's not like a trade show where you got to buy the power box from the union guys and pay them to do everything.
Stephen, are you coming? Stephen Morocco? Yes?
That's a
Yay.
yes. Okay. Michael, how about you? Are you still in California? Michael Park?
There's 3 Michaels in this meeting today, so.
Yeah.
Michael Park is in Seattle.
Ah, okay.
Oh, Ari Alvarez is in Spokane, Washington. You're close to me now.
Yeah, apparently, neighbor. I'm actually getting a little I wasn't planning to, but plans are changing. It might happen. So cautiously optimistic.
Just being conscious is a good start.
So remember, if you are coming, make sure to sign in the Eventbrite in the page so we know you are coming. Steven, do you need a table? No?
Nope, I'm coming to enjoy others and what they're showing and just relax.
We'll have to have a Visual Studio Code setup going with our TS compiler.
Oh, okay, sure.
And it would also be good to have Microsoft stuff shown too. Actually, you know what? That is what JonnyMac uses. So he'll probably just have that running anyway.
Right.
And right now I can see in the list 2 presentations, and probably we need to schedule some more presentations there to show real time. It's much better for people to ask questions right on the spot. All right, I will read it for Michael Mulholland. So, Michael, do you know that you are making a presentation now? Are you?
Yeah, well, not a huge presentation. It's kind of a quick part 1, a quick taster of what I was up to. Some of you may have seen in the forums. I was asking Eric about the compiler sizes, or the compiled compiler sizes, because I was trying to fit the OpenSpin compiler into the wireless module. And yeah, it's a little bit tight when you've got, I think, 600 kilobytes of SRAM and not much else, maybe 4 megabytes of flash. But anyway, not being deterred by a challenge, I found a Wi-Fi module that gives us the sort of memory we need, at least to get proof of concept, and certainly the chips, once we lay out our own board, will give us access to 16 megabytes of PSRAM and 16 megabytes of flash and stuff like that. So we could do loads of things. And so the idea is that if we were to make a self-hosted board, which can actually compile the spin code, then we've got great options for the future. You know, we could, if you imagine Blockly Prop in the classroom, that could just be hosted on this wireless device. You wouldn't have to have an internet connection. You just have to connect to this thing either through Bluetooth or as an access point, wireless, and then you can have a web page and get coding. We could extrapolate a more simple coding interface. It could just be drop down boxes and select pre-stored libraries and give it some IO pins, and away it goes. And you could code on it as well, certainly copy paste or upload code. So I got as far as actually having the thing working, which was quite nice. I then proceeded to break it, and I've just spent sort of half an hour trying to make it
Yeah,
work
this
again.
is what always happens to me. You're under the gun and things blow up at the last minute.
But I do have, actually, I can share the screen so you can actually see a compiler working. It's not super interesting, but it kind of give you some, it'll give you a taster for where it's going. Because it's so tantalizingly close. Now, gosh, how do I share? Here we go. Right, I'm just going to share my screen. I'll just share the whole monitor.
So the open spin was written in C by Roy Eltham a while back, right?
Yeah, absolutely right. And it's on the Parallax GitHub site. I looked at a couple of options to start with, and I sort of went with the one that gave me the least trouble. Ultimately, having learned the process with OpenSpin, I mean, OpenSpin was essentially the smallest amount of code to start with, so therefore it seemed like the obvious choice for learning this process. But now that I've figured this out, yeah, the next step would be to put a Propeller 2 compiler on there, and the options are either Eric's FlexPin package or possibly Peanut TS converted to C. But I'm not yet there yet, so I don't need to quite make that decision yet. But yeah, we'll certainly progress and have the P2 compiling on it as well. A lot of the work was really moving anything that was using stack or heap, especially dynamically allocated stuff, out into PSRAM. So that really was kind of the main thing. Oh, well, I've probably screen shared already, which is probably not that interesting. But if I just run the code, just to make sure, oops. Just uploading now.
So we're looking at a serial terminal conversation in this main window here, right?
Yeah. And so where I got to was that I had this, I've got this running in console mode. And then a couple of days ago, I decided to move it or merge it in with my web application so that we can actually drag and drop, because I have like a drag and drop web page thing here. So you can just drag your files in. And in theory, it spits back the binary here. And then the next step would be it would also program directly a connected Propeller chip. I've already written that code in C on the old Wi-Fi module, so we know we've got that bit. But this would sort of be the first step to get this working as a fully fledged compiler. So for next live forum, we'll certainly have this running. But yeah, that would be the idea, that you drop your files in here. I'd like to be able to drop a zip archive. I don't know if I'll get that far. I might just drop a folder of files in here. But we'll see where we go. And then it will spit back the binary into a text page thing here, I guess, or certainly more importantly, upload it to a connected Propeller chip. And then, so this is sort of the output. So it actually is functional. It sort of goes through, there's an awful lot of watermarks and guard bands and all sorts of stuff there. But you can see it basically builds up and loads in all the Propeller key or symbol table. I've got a PSRAM usage report that I can track all the way through, so I can actually see how much of all the different memory regions are being used in the process. So an awful lot less than the sort of numbers that we were discussing in the forums with Eric. And this is really key to it. So yeah, the process, well, if we get to the end, we've used about 15% of 6 megabytes allocated memory, so not really much at all. Well, we can see there the peak usage was only 6.8%.
But wait, how many megabytes was the peak usage? It was,
well,
about 4?
I've allocated, yeah, I mean nothing really. I've allocated 6 meg, and not much is used out of that.
So the allocated space, that 2 meg, that's probably the compiled open spin program, right? Mostly.
Yeah, mostly
dynamic memory.
Yeah, I mean, to be fair, I'm compiling a ridiculously small program for this quick demo because, as I say, I just started porting this over to the Flash filing system version, and I haven't quite got that working. I've got lots of Stack Overflow territory when I've started merging into Flash, so I need to deal with that. I'm obviously hitting I'm hitting one of the pointers, and it's going wonky, but that's fine. Yeah, so up until that point, it's yeah, I mean the compiler data is a static, so it's not tracking that at the minute, but we used 246 K, and yeah, the object buffer is a fixed size because that's the final image, which is twice the maximum. Doesn't need to be that big. But yeah, so I mean, really, we're kind of allocated for this compiler process, just under 3 meg. And we're not really using all of that either. We could probably merge some of these categories as well. These are just the original categories that OpenSpin used. And of course, it was free going with its memory allocations because it was running on a PC. But we can certainly get some of these down, and then we can reuse these in a lot of the other programming. So we've got really a huge amount of space, and this is just PS RAM. So I suspect we could probably get this down to about 1.5 meg, although most of that is reserved for the the program. So depending how big your source code is, that's going to have the ultimate well, is it though? Because of course the source code will be saved to flat. Well, no, temporarily we'll probably dump the source code into a PS RAM buffer as well for speed. Anyway, loads of space. Yeah, so you can see here it goes through and it finally compiles it, and it just spits out the binary buffer. So if you uploaded this this sequence of binary bytes into a P1, it would work. It's basically a binary file format. So it's a successful compilation. And then yeah, and then it would just go on. But this is where I ran out of time to figure out the Stack Overflow. The actual compile thing is using hardly any stack. You can see that we've still got 32 on the stack, 32K on the stack remaining. Although it might not be bytes actually, because it would be words rather than bytes. But anyway, whatever. A lot remaining. Yeah, so the next part is basically merging in the web application. So the way the web application works, it basically uses the Flash file system. So we can drag and drop. We'll be able to drag and drop files into here, which will then save them into Flash, probably via a PS RAM buffer, compile them, and then save the compiled binary into Flash. And also allow you to download that compiled file binary through the web page and load it into a connected Propeller. So that last little bit is just not quite there, but we'll be there next time. But it was quite interesting to convert OpenSpin to run on such a small little platform. And as I say, most of the key was a lot of logging to figure out what was going on with the memory. So adding,
that's
that was key. And actually before this, I profiled the memory usage on the original OpenSpin running on the PC. So I added some memory watchers to that, and I could see how much of all of the different types of memory were being used. And that's where ultimately I could get some of these values for. For example, the hash tables I knew was, the elementizer was a fixed 324 bytes, and the hash tables headers were using a fixed 48 bytes. So I could allocate quite accurately, small sizes for certain things, knowing that they never grow from that size. That's just structures really. And then other stuff is variable. Compiler data is the big one. So for now, I just allocated a meg on this thing.
Does the compiler have any kind of internal like dynamic memory allocation that it could then like call you to allocate more PS RAM space? Or because I see what you kind of done here is you fixed the buffer sizes for now, right?
Well, these are dynamic, so it has a maximum size for each buffer.
Okay, got it.
But then I allocate the memory as I go dynamically. So like when this was printed, and I print it out various times through the process so I can see what's going on. But you know, I can see the current usage and the peak usage. And so you know, at the end of the process, I can see what the peak usage was
I got it.
in any of the buffers, so that they are dynamically allocated. Of course, at the end here, they're probably all matching numbers, but yeah, so it is dynamic.
So this is kind of interesting. There are like many levels to how all this stuff can happen. Like I think Eric Smith's here, maybe he could comment. I wonder how much like his whole code and environment require to operate. Now I know in the case of the Peanut TypeScript compiler that Stephen and I are working on, the whole like correct me if I'm wrong, Stephen, but the JavaScript environment combined with the tools and everything has a need of about 45 megabytes of RAM, right?
On file system, I don't know about RAM. I've never profiled it to see how much we run with.
Okay, but the file system.
All the internal tables expand as needed. And so, and we have fewer table limits than Peanut does, although we still have some of the same limits as well. So I would expect that given a JavaScript runtime environment, the performance is going to be a little bit slow on that kind of device, but it's not impossible. And so if you don't do the translation and you provide a JavaScript environment, that adds capabilities behind the web server, and it also gives you the ability to just run the compiler as we have, right, without translation. So it all depends on the richness of the JavaScript runtime that you choose.
Okay.
Well, for FlexSpin, I can actually, for FlexSpin, I can kind of tell you how complex that is. So what that does is it's basically not developed to be very efficient. It's kind of just works.
Right. It's to get a job done on a system where these constraints don't exist.
Yeah, it's like if you just look at the executable, it's multiple megabytes. What it's like just because there's a lot of features. Even though it builds like 3 different executables, they're actually all the same. They all include the same thing. They just take different parameters. So there's a lot of duplication between those. And my main thing that I worked on is the optimizer and the sort of IR compiler. And that would be very inefficient if you tried to move this into like a non-addressable memory, like a PS RAM. Like you can't just access the PS RAM directly, right?
Right. You have to bring in cache loads of it.
So anyways, FlexSpin creates like a lot of objects on the heap and puts them into linked lists, and then goes over those linked lists like, I don't know, hundreds of times. And then it finally turns that into a text that will then into the assembly text, and then it reads that back in, and then it assembles it, which is a whole nother thing. So
it's actually very similar to how this works. It definitely works in a very similar way, that you have the recursive compiling phase, and then it works through each of the objects, stores them, and then finally reassembles those, and and then spits it out.
Yeah, I mean, in principle, we could create a version of FlexSpin that just had spin and didn't have the C or the basic.
Or list.
And that would save a fair amount of memory. But actually, I think Peanut TS is promising in the sense that if you could serve up the JavaScript and have it run on the user's PC, then you wouldn't have this memory constraint.
Right.
That wouldn't quite meet the goal for this specific thing, though, because we want to be able to so we want to be able to compile the code in a device that doesn't rely on a web browser, if that makes sense, and to provide a way for the user to adjust parameters before it's compiled.
How,
What
how
I mean
does,
by that is it doesn't rely on the client side.
Well, that maybe there'll be some sort of client side, but it won't necessarily be a full-blown browser experience. It might be a Bluetooth interface. It might be some other interface. And yeah, there's a case for a full-blown environment, of course. But in the situation where you just want to be able to adjust I/O pins, for example, maybe enable or disable certain features on an I/O pin, which might be an ITC library, it might be whatever it might be. You may not need a full web interface for that.
Michael, another question for operational. You said that you compile and then you dump the hex to binary. Are you thinking of ultimately just writing the binary to the flash files to the flash, and then letting the interactive interface load that and run it?
Yeah. So the idea is that or what it does now, it saves it to flash. Basically, it's just the classic little FS running on this thing. So it saves it to flash, and then it will, when I add that bit of code, it will download it to the P1 or the P2 directly. Yeah.
Okay.
When you say little FS, do you mean the thing called little FS, or the file system that we made that is little that runs the flash?
No, I'm talking about the original little FS. So
Okay.
yeah, because that's not on a P2 or P1. It's on the Wi-Fi board, right?
Yeah.
Oh, I see. Right. Okay. Gotcha.
Now, how are you planning on configuring the Wi-Fi board? And I'm not sure I understand what you mean by PS RAM then so far. By configuring the board, I mean external RAM, external ROM.
Yeah, it's these little chips up here, right, Michael?
Yeah. So the Wi-Fi module has
some PS RAM.
It's got some internal PS RAM, and you can add external PS RAM and external flash. So we'll just make a board that has, the amount we need, sort of thing.
And it'll be accessed normally addressable, but through SPI interface or something like this.
Yeah. QSPI, quad SPI. Yeah, to get the speed up as fast as possible.
Right.
It was actually interesting because I still had to override memset and that to, add some little teeny delays in there just to slow things down a little bit. But having done that, it works, flawlessly now. So it's now directly addressed just like, just as any of the other memory ranges.
So are you running, is this all native? Is it running a small OS or is it native web server and everything?
So up until a couple of days ago, it was just running sort of bare bones, but now I've moved it into, and this is where it's causing me slight new gremlins, is I moved it into RTOS because I wanted to have a threaded environment for the Wi-Fi stuff.
Good.
But in doing that, I kind of got myself into a mess with figuring out what it was doing with the stack. Well, I can see it's allocating it in the heap area.
Right.
But so it's kind of trampling on itself a little bit. So I need to sort of straighten that out.
So RTOS is running on the Wi-Fi module, which has what kind of a processor in it?
It's Cortex M4.
Okay.
Have you found any multi-core versions of the Cortex that run the ESP?
No, and it's not ESP if you're talking about Espressif.
Okay.
But no, I'm just sort of using the stock chip that would be the thing we could buy and realistically put into a module that's pre-FCC approved. And
oh, gotcha. Yes. Did you say exactly which module it is? Pardon me for missing it.
Maybe I didn't, but it's an American-made wireless module put out by Scilabs.
Say that name again.
Scilabs, Silicon Labs.
Scilabs. Okay. All right.
So the intention as well is also to try to use American 4 module, American communications module.
Gotcha.
And the other nice thing about it is that it also has a mag port, so an Ethernet connection. So we could use a cabled Ethernet connectivity using the same software environment and the same chip. So it kind of gives us the things that we could use to grow, you know, because from that we could then look at possibly power over Ethernet powered, you know, modules, and the list goes on. But yeah, so it's sidestepping a little bit from the existing wireless module.
And is this the wireless series 2 that you're looking at?
I'm not sure what they call it. I mean, I can give you the chip ID, which is 917.
Okay.
SiWIX 917.
Looking. Gotcha.
And there's a whole range of those, but they do some that come in a metal tin as well, which are you know, approved and ready.
Right. So it's a MCM kind of thing that you just put on board.
Yeah.
And it's like an 8, you said it was about $8 or so?
Yeah, something like that. Yeah. Yeah.
So
Maybe
it's the
6.
Cortex M4 with some Wi-Fi and wired Ethernet connector that's pre-FCC approved and has enough memory and everything to be able to run the compiler to act as like an intermediate between any kind of host system and the P2.
Yeah. Yeah, and they do a version with onboard PSRAM and external flash, which is, I think, possibly the way we'd end up going. Although, you know, it might also be tempting to share external PSRAM with a P2 and then use internal flash. Although I don't really like the idea of internal flash because, you know, it's good to be able to replace flash, I think. But we'll see. We're not quite at the stage of worrying about the hardware specs yet, other than to, you know that it can do it in some shape or form. The other thing I was going to say, and maybe for Eric as well, that so one of the big other memory savings in getting this open spin code base down was just stripping out the list and anything to do with documentation, which, you know, dynamically allocates a lot of space as well. And so, because in this environment, we don't need, you know, list files and doc files,
Right.
maybe some other stuff. So so there are some areas that could be excluded from, you know, probably the FlexProp thing.
Oh, definitely. Yeah, there's a
to
lot of stuff.
bring it right down. Yeah.
Yeah, you'd only want the binary output. You wouldn't care about, as you say, assembly listing or the option to produce bytecode or, well, I guess we might want, but that's a good question. Do we want bytecode or not? But we could produce a version that only output the assembly.
Yeah, I mean, ultimately, we just want the binary format, so that could just be uploaded over UART.
Well, FlexProps gives you a choice of binary formats. You can output like the P1 bytecode that the ROM interprets, or you can output an executable like a P1 instructions that are directly executed with LMM.
Okay. Yeah.
You'd probably, I guess in that case, we'd probably want to build like 2 separate compilers or something and have a choice, or we just settle on one and say you're,
I think we just Yeah, just because that for this specific application, you know, obviously other applications you might want other things, but I think for this we just want one and just, you know, probably whatever's the lightest weight, I guess. And
Yeah, that makes sense.
it was quite fun when I started it because, yeah, one of the early steps was to get rid of the config struct as well, which was not insignificant, and you know, just switching out lots of things to either true or false as defines, and then going through the code and finding, you know, and then doing global search and replaces, and then going through the code and finding lots of statements where it's like if true equals true or false equals false.
Well,
So you can just
a good
strip all those
compiler
out.
should take care of that for you, like GCC or Clang.
Yeah, it'll remove that.
Yeah, it's just funny to see it when once you decide that you don't need all the options. So that's basically you know, where we kind of went from that forum conversation, and yeah, the first step was to get the compiler running on the thing, which it works quite well. And then yeah, the second step was to get the Wi-Fi connectivity working, which I got working. So you log into this page and you can search for local networks. So you can connect to it as an access point, and then you can search for local networks and then choose the one you want to connect to, and do that stuff. And now I was working on I was just working on the flash upload basically. So you can just drag and drop a file into this web page, and it would compile it then, and to start with just save it to flash and then just spit it back to me, and then the last step would be just to bring over the Propeller programming code. Yeah, so I think we can have all that in place for the next live forum, so that'll be sort of job done on this, and then we can talk about hardware. So that might be quite a nice segue in hardware. Oh, and just while I've got the microphone, just some information to share, which has really nothing to do with this, but JonnyMac sort of got us thinking the other day about using the edge in a way that could be more compact. And I've spoken to our connector manufacturer who makes the edge sockets, and we're looking at reducing the height of the socket, which is currently, oh, there we go. Thanks, Chip. So it's currently 50, rounding up these numbers, it's currently 15 millimeters tall. And so we're trying to see if we can get it down to closer to 5. And that would apply as much to the right angle socket as it would the vertical socket that Chip just showed us there. Yeah, so that's sort of in discussion now.
Yeah, that would bring this thing way down, and it would allow it to mount, you know, very flush to a board.
Yeah, because the actual edge module in itself is pretty compact, and because it's got such a thick slug of copper in the back, the heat performance is pretty good, and the top end speed is pretty good. We just don't have. It's just the socket just seems to be a bit bulky compared to the size of the edge module. It's sort of disproportionately large. Yeah, so just sort of to share that little insider news that's sort of going on. We're trying to sort something out there.
Yeah, because so much engineering went into this thing and the thermal characteristics that we can't really, I don't think we can really better this. I mean, if we can just get the connector down, that would be a big win, but we even have room here to put like a Wi-Fi module or something. But this is really refined. A lot of good effort that was fruitful went into this thing. It would be good if we could more easily keep reusing it, but this giant socket here is kind of an encumbrance.
Yeah. Yeah.
Well, thanks for explaining all that, Michael.
Yep, that's what I've been up to on the compiler. So, but it would be interesting to see if well, we'll have to see where we go. Perhaps when this is finished, we'll sort of turn our minds to what we do with the P2 effort. But I think it's worth waiting for Stephen and yourself to finalize the TS, because we kind of have to decide which, we only want to do this exercise once, and we have to decide where to start from and which is most plausible. I actually quite like Eric's I quite like the concept of using Eric's system, because we could possibly get, I know you just talked about removing them, but we could possibly get C and basic as well, all in one. Yeah, but it might just be a stretch to get that converted. That might just be too much.
The C,
it felt like that when I looked at it originally. And
the C preprocessor is one I took from somewhere else, and it is a memory peg.
Yeah.
It routinely allocates a megabyte for any string that it.
Yeah, so that would need quite a lot of refactoring to bring that to heel.
Yes. The spin and basic are not so extravagant. I mean, they're bad, as Ada said. They just assume unlimited memory. But at one point, I actually had an alternate memory allocator that was intended to allow the code to be reused as a library. And for spin and basic, that worked reasonably well. And I don't remember the numbers, but it usually wasn't more than a few megabytes that it needed. But for C, it just exploded, and because of the preprocessor.
Yeah, all this memory stuff, because I started a long time ago and memory was always at a premium, so it was important to squish everything. I've never gotten out of the habit, and I really have this like unbreakable desire to make everything super small and efficient, even though maybe it's kind of passé. I still just love that stuff. In fact, Michael Park that's here. Are you still here, Michael? Let me see. Is he still here?
Here, I'm here.
Yep. He, back in, was it around 08 or so, he had the Sphinx thing running, which, the P1 only has 32 kilobytes of RAM. And he had a spin compiler. It had to run in two pieces, I believe. But he was running, with code and data, the whole thing in 32 kbytes. But it had to run in two parts, as I recall, right? You'd first run a compiler and then some other thing to do the other half.
Right, and it saved temporary files to SD card.
Okay. Yeah, that was cool. I just looked now as we were talking, and the current OBJ for the P2 compiler that's, of course, written in 386 assembly, the OBJ file for that's like 95K. And its memory requirements are kind of big because I just allocate a lot of big RAM for buffers, but that could be made dynamic and much smaller. And then back a long time ago when we made the what was it called, the basic stamp, that whole application was a COM file. If you remember in the DOS days, the .com programs, and that whole thing, it was like an IDE with a little debugger and and the compiler and everything was 13 kilobytes.
So Chip, on
Size
a
of the
PC, if you allocate memory and don't use it, it's actually not real.
We allocate memory and don't use it.
Yes, often the OS will just not give you the page until you actually use the
I see what you're saying. Yeah, right. Yeah, I mean, of that 13 kilobytes, I obviously had some buffers that were needed, but the actual code to do everything was 13 kbytes. Things have like grown by orders of magnitude.
I have to say, it's been working with Chip, it's been amazing. We have similar backgrounds in terms of starting with 8-bit processors and other small things, and also mainframes for me, but it's been an excellent reminder and tutorial of those days for me as we're working day to day.
Well, to me, those concepts seem timeless. I mean, when is it a good idea to waste anything?
Right.
Right. And so, I
I'm
mean,
following you. I'm enjoying it.
yeah, I don't know if it'll ever come into fashion again for any reason, but I love just making stuff small and, efficient. Ari, anything else on the schedule today?
No, and we have Ken listening. He's driving right now, so he's listening what's going on, but everything he had to say, he put in the notes when we open, and yeah, that will end the program, so we are open for discussion.
Yeah, we can talk about whatever anyone wants to talk about.
And
Well,
depending what you talk
I
about,
can
I will end the
actually show
recording.
you my new favorite P2 board that I've, because people keep sending me them.
Okay. All right. Stand by, Michael Park. I saw you started to speak.
Where's the
Okay.
Where's the camera? There it is, buried underneath the mess. Anyways, this is let's see if it picks up the camera. Does it?
Yep.
Yes. So this is, it says Propeller 2 platform on it. And this is the new board from Race Logic. And we can take a little tour of it. You can see it features a fan and the header to power it. Just so it stays cool, even if you put it into like an enclosure or something. You get a USB Type-C programming port.
Nice.
An
So he has
SD card slot.
some kind of
and
prop plug built on then.
Yeah, it has the FTDI thing built in. It has an SD card. JonnyMac always complains on the forum about the SD card being shared with the flash. This doesn't do that. This is just on a separate pins, and it has all the pins brought out, and the whole transistor power cycling shebang, so it can use the 4-bit driver by Evan, which is ostensibly 4 times faster than normal. You get one 8-pin I/O and another 2-pin I/O, another 2 8-pin I/Os, and yeah, that's all of them. That's kind of the downside. You only get the 3 headers here, and you get this sort of unpopulated thing. You can see peeking out there under the fan, there's some PS RAM chips. There's another row for 64 in total, 64 megabytes. And there's one of those quick connectors, which I haven't tried, but presumably it's connected to something.
Neat.
And there's this voltage regulator section somewhere up here. You can probably not make it out, but there's a little solder jumper over there, which will actually raise the 1.8 volt line to 2 volts. And what that does is it makes it not crash all the time when you're overclocking.
Oh, okay. Yeah, so how fast can you run this thing?
Well, it runs all my stuff that I've written with the overclock, which sometimes even the Edge doesn't really run it that well.
And that's your stuff runs, is it 343 megahertz or something?
This should probably run up to 350 with no problems. But Ray claims he's got it running very light loads at 400.
Whoa.
Which I'm not entirely sure if that's real, because someone on the forum claimed the oscillator can't actually go higher than 360.
Oh,
but
yeah,
I guess
true. Yeah, I think it's 360 something.
Maybe that changes too with the voltage. I don't know.
And it's very much code bound as well, and how many cogs you're running and what code you're doing.
Yeah,
how
certainly.
much heat you're generating.
Well, this generates even more heat because it's higher voltage.
Yeah.
It's got the fan on it for that evident purpose. You kind of need a fan anyways. The P2 Edge needs a fan, as we know.
If you're overclocking, yeah.
I mean, I don't know what depends on definition of overclock, and depends on are you just having it on your desk at normal room temperatures, or having it in some sort of environment that's hot to begin with, or in like an enclosed space where it can just build up the heat. You probably do want that regardless. So anyways,
yeah, because the
cool
spec
board.
that's why the rated temperature is obviously much lower, because it's spec'd for being, in a enclosure, or in a, I forget what the ambient was set. I don't know if it was 25 or if it was set higher, but yeah, certainly that's why the spec is much lower.
Oh yeah, and he also gave us this wonderful nugget. This is let's unplug the stuff from it. It's easier to see. This is a board that plugs into the double eval type headers, and it's basically just the VGA part of the VGA and the audio part of the AV board and the USB board consolidated into one thing. Which, if you think about it, makes a lot of sense.
Oh,
Totally.
interesting.
It even has this onboard microphone thing.
So it has a VGA and a stack of, are those USB connectors?
Yeah, that's the USB connectors. It's really just, let me grab it. It's really just the two, these two. That's not in frame. It's really just these two eval accessories.
Okay.
But combined into one. The only criticism I have of this is that it's reverse from how I usually have it when it's plugged into that board. Normally, I would put USB at 16 and VGA at 24, maybe. This is reverse. This will, if it's plugged into this, have USB at 24 and VGA at 16, which is a bit. It doesn't actually make a difference, but I hate it. There's also this alternate version, which evidently just has an HDMI port on it, ostensibly equivalent to the VGA port, for less parts on the board, of course. And also, for some reason, the utter clown didn't solder down the HDMI connector. I think that doesn't come through in the video. But like the shell solder points are just not soldered, it just flaps around, held on by nothing. Clownish behavior. I have to fix that. He also sent me this this LCD board, but I think he never sent the datasheet for that, so I don't know what to do with it. Look, it's still in the packet.
Ada, did you mention who made the boards?
That's the Race Logic
Okay.
board, the new one. The old
Very
ones also exist, but they kind of suck. Yeah, I am allowed to say that the old ones suck now that this one exists, which is just infinitely better. I don't even know where I put that one. Did I use it as a coaster or something? No, I wouldn't do that, but I don't think that's healthy using your boards as a coaster. Yeah, the other one's just kind of gone. I had it just the other day, but it's gone now. Gone with the wind. Anyway, LCD board that's in a packet. You can't see it because I have a camera that's from like 2000 something. It uses USB 1. Clearly the highest of technology. Now, he said he's going to have these boards available for spring break, he claims, with his new pick and place machine. So look out for that one. If you need a development board that isn't like a giant Lego piece mess, like the long breadboard is. Just a mess, that one. Compact, nice, doesn't monopolize your desk. LCD screen that I have no idea how it works. Does that have some sort of IC on it? Is that anything? Who knows? Anyways, that was that.
Thanks. Thanks. Michael Park, were you going to say something?
Oh, I was just gonna mention in the chat, JonnyMac mentioned the P2 stamp. Still like
Oh,
to
we
have
have one of those as well. After
So yeah, I
Time
think
for
what
that one.
John's saying is he'd like to see one. But what would that be like what we discussed with, say, like the castellated edges and the
yeah,
QA?
that's the little thing that plugs into like the PLCC socket.
Yeah. Yeah, we Michael Mulholland and I, we've been talking about what can be done to, minimize the footprint of this thing. And we're not sure what, if anything, to do exactly. But Michael did, bother to contact some connector manufacturer and see if they could just shrink because this thing is kind of a deterrent. I mean, these are very inexpensive, but they're just so huge, We need something that could allow things to get closer down to the board and, not even the right angle version of this is horrendous too. It has pins that come way out and go down. We just need something better. And then if we make, redo this with some IO, it's hard for us to know like what exact kind of IO we should put on, but we're thinking maybe a couple USB connectors, a HDMI connector, some IO pin headers, but something that's nice and tiny, but and kind of something that would lend itself to becoming a standalone platform that we could then easily standardize software efforts on. Because this is very open-ended, you can do anything on any pin, but it might be good to have some known connectors at certain places, and that could,
Yeah, that's always a huge mess because you always have to edit around. Like I have probably every P2 board that ever has existed. Don't ask how that happens. And I have like in every project, you can't see it on the GitHub because I don't commit those. I have like 5 config files. Like no, not 5. Let's actually
for all
count
the
how many it is.
possibilities. Yeah, this causes us to waste energy in a sense.
I have config eval, config mxx, config p2 plat, config p2 stamp, config race logic for the old race logic board.
So a
Just config, which I
standardized,
think is for the eval. And yeah, that's 1, 2, 3, 4, 5, 6. And they're all different. And if you load the wrong binary, it will probably explode or something.
Are you saying that you can't upload those somewhere?
I could if I wanted, but these are all just horrible. You can just make your own very easily.
Sorry, I misunderstood. I thought you were saying that there was a problem with sharing them at one of the sites. And maybe if that was the case, if I knew the file extension, I could certainly add it so that you could then upload them if that was an issue.
No, it's just that every board is kind of different. And with something like the eval board, you can kind of just plug it up however you want it to be, which a lot of people have actually asked me where they should plug the accessory boards into like the eval or the breakout boards. But I'm like, no, you put them wherever you want and you change the config.
Yeah, but it makes it very hard to just give something to somebody that's going to work.
I mean, this one. Look at this one. It's good. With the HDMI and the USB, look, it has 64 megabytes of RAM. Look.
So, do you think?
I mean, what we've been
or the other one from the Italian guy, Massimo. Look, I have one. That one's also good. That one has just everything built in, but no IO other than that.
Yeah,
Do you
it
think
might be
90
closer to the thing we were looking at, but our intention is to get everything all on one board, so no breakouts. So it will be something akin to the original P1 demo board. So it'll be a USB-C powered P2 chip, bunch of PS RAM, and HDMI port.
And that's the previous generation of Race Logic board over here. That one did have all the stuff on board. It's basically that, but this one had bad thermals, no voltage regulation hack that makes it run faster. Just crashes all the time. Shitty board. Also didn't have the high-speed SD card stuff. Not a cool board. I don't like this, but it has 64 megabytes. This one, really good board. Which, if you look at it, if you squint, these are just the same board but slightly different. There was an even earlier one that had that was like this, but it had the headers on. But instead of the USB stuff, I don't know where I put all of them. There's so many.
So
also that P2 stamp again, just for the funsies. Where is it? Oh no, it's not in range of where I can point the thing at.
Ada.
There's the P2 stamp again.
Ada, I have a question for you. Oh, that's pretty good. That's very tiny.
Yeah,
and that socket doesn't have too great of a an addition on area.
Yeah, this is really easy. You could probably solder this down maybe on a board if you wanted to.
Yeah.
And the downside with this one is that it's really tiny, so it gets really hot. It doesn't crash somehow.
Yeah.
Like this one's well, but it even has the little SD card socket on there. That's an SD card socket.
Ada, do you know about those PS RAM chips? The 8 meg by 8 is the most available one, but there's also a 16 meg by 8, right?
No, it's one company was listing it as sampling, I think.
Okay, but it never got anywhere. So 8 megabytes by 8. So how many megabytes? I mean, to run your emulators, for example, we would need
well, it depends. For the Mega Drive emulator, just the single 8 megabyte chip is plenty. For the SNES emulator, you probably do need the 2 in parallel just for speed, I think. Maybe. And I think there's like some games that are actually larger than 8 megabytes. But the requirements there are not very high. With the Neo Geo emulator, it also doesn't actually have that high requirements. You probably just need the 2 in parallel to make it. No, actually, I had it working with just the one 4-bit setup. If you have multiple chips on one lane.
Okay, but 32 megabytes is not really enough to run some of that stuff you're doing, right? You need like
it's enough. Times that. I mean, I developed the original version on the P2 Edge, but the problem is with the Neo Geo emulator, some of the games just get huge.
The Neo Geo, yeah, that's where you had 96 megabytes.
Yeah, but 64 is also pretty much, like, it doesn't do everything, but it runs a lot more than 32.
Okay, so that'd be 8 chip. I wonder, Michael, what if we made a board where we put down 4 of those things like we have now, but then we had extra chip enables to run like 3 more sets of 4, so we could go to 100.
Yeah, that's how these do it. Look, it's just 4 in it's 4 lanes here.
Yeah.
This has it labeled wrong. This is incorrect. I have the correct labeling. So
the footprints for these are nothing. I mean, if we had a total,
yeah, these are the big ones. These are the big ones.
Yeah, I see the tiny ones are like these little tiny things that look like.
Now, Massimo actually is working on a new version of this thing, and that's also going to be like that. It's going to have the 16-bit bus, but with 3 chips on each lane.
Okay, yeah, 16. I think 16 bits is kind of the sweet spot because you get a lot of throughput, and to go higher, you go 32 bits, but then you've just eaten half the I/O pins.
Yeah, that's not really very productive.
Right. All right, here, I'm gonna turn on my little other camera. Let's see. Where's my cursor?
And I think the 16-bit really is the better idea. The problem is that so this no, that's my desk is getting a giant mess. You remember this thing, right? This is the original Race Logic 96 megabyte board for the eval.
Right.
This only works because it only has 16 pins in total. It has to put 6 chips on each lane.
We need
right, so it's only got an 8-bit bus. So not only, but it's not actually half the speed, because due to having so many chips on the board, it actually doesn't actually work at the faster speed. So it's actually like a third of the speed of the edge.
Right. Now we need,
which is not very ideal. It works for the emulators. They don't actually need the throughput. They just need latency and space. And yeah, you could say this is a shitty design. I think Evan on the forum said this is a shitty design where all the traces just go weird. But Massimo's thing uses the same layout, and it also has the same problem, but less severely. So this is just this is good for capacity on low pin count, but it sucks in every other way. Just slow and horrible. With this setup, this kind of setup with the 16-bit bus, you have a lot less load on each data pin, so that's why it works.
Right.
And
what we need to do is mount it super close.
I made a memory stress tester program once that just sort of reads randomized and specially picked patterns from, well, writes stuff to the RAM and reads it back and checks if it's okay. And it just does that in a loop. And it will tell you if any one of those reads had a bit error. So that program usually works for like hours on end. Like you can run it for a really long time. And on a good board, you will just see okay. And I did recently get an email from Massimo, where he showed a screenshot of that thing with a 96 megabyte setup that did have a path on that. Let's see if we can.
Is there any value in having 128 meg available?
I mean, you can find uses for that probably. Well, you probably run into the same loading problem again. We know that 3 chips is fine, but 4 is sort of uncharted territory.
Oh, 4 per bus, 4 per data. Okay, so 3 is okay, but 4 overloads. But has anyone ever done?
But 4, we don't know if it's bad. It's just so happens that all of the boards that I have either just the 1, like the Edge, the 2, like these 64 megabyte boards, the 3, like this thing here, and allegedly the new board from the new MXX board. And then we have this with 6. 6 is bad, 3 is good. We don't have any data for boards with 4 or 5.
But has anyone known? I mean, if you mount these, I wish I could get my documentation camera going, but it's having issues. But see those 4 little things right up here? Those are the surface mount versions. See how close to the chip they are?
Yeah, they're smaller and better. So that's what Massimo's using in the new version of his thing, even too. So
yeah, I mean, I think if we packed potentially 3 more rows, I think electrically it should be sound. There's not much wire loading there, and I don't think the capacitance of those pins is very much.
Yeah, you could probably make that, but if you go with 96, it's probably more proven.
Okay.
To be safe. Just
right.
to
so
show off that
more chip select pins.
That proof. Look, he's been running it for 18 hours. That's 18 hours of testing at 338 megahertz in fast mode. And look, all the banks are okay. And each bank is 8 megabytes. Each chip is 8 megabytes. So you can see there's 4 lanes, 3 banks.
32 megabytes.
So each bank is 32 megabytes. and each lane has 3 chips on it to make that happen. It says 41,000 iterations. So that means it's read and written every memory location 41,000 times and didn't get a bit error.
Good.
And it writes a mix of random data and like data that's specifically designed to mess up the like on off kind of signals that will cause errors. And like adjacent pins toggling and stuff like that. But yeah, 96 is pretty good as far as.
So Michael, that would support 2 more sets of 4 chips. We'd have to have 2 more chip select pins. Well, you're muted. Now talk.
Unmuted. Yeah, this was one of the castellated modules that we had. Although this had 64 megabytes RAM on it, an RTC. But you're thinking now to go up to 96 megabytes.
Well, if we did, we'd need 2 more chip select pins. But Ada's emulator needs that much memory, but I think probably most customer apps wouldn't. I mean,
64 is even fine. It's just the one emulator with some specific games that needs the 96.
Okay. Yeah, well, so these chips I see from Adafruit, they're like $1.75 each, I think. But we can probably get them for $1.30 or so. What do you think, Michael?
Yeah, I mean the chip price isn't the.
Yes. So
It's
4
quite
more
reas-
of them
yeah,
would
quite
be like
reasonable.
$5 maybe. And then we go to 64 megabytes.
Yeah. Yeah, they do
Okay.
fit well. No, we'll have to look at it. We'll have to look at it.
So I have a question. I'm not sure if I understanding the request correctly, but I think that some people are requesting a very small minimum common denominator, like the basic stuff that you need to run, no extra stuff. Ada mentioned that every board that we make and it has fixed resources, then you need to have a different configuration, or you may have extra memory that somebody doesn't need. So that takes the pins that they may need for something else. So I'm not sure what the request is. If it's a minimum setup that anybody in their own projects, they can expand and do, whatever they want, or if you have to have some resources there because they need to run at some speed or something. Because what I'm hearing is asking, I think, for small, simple, inexpensive, something they can maybe solder to their own board, maybe even without pins added, similar to the flip, but even simpler. Not sure if I understand it, so somebody wants to chime in?
About the edge, I like that there's only the few pins on the top there that are dedicated. I like everything else wide open.
So you don't need PS RAM or anything.
Yeah. Those 2 options are fine. I can see the need for PS RAM, and if you're going to have it right on the edge like that.
Yeah, it has to be there.
But I've got uses for both, and yeah, I like the open-ended. The sockets are a bit chunky, but I am not one for everything's too damn small nowadays. I don't try to fit into smaller things. I mean, I've got this is my geek port, my open-ended test thing that I do a bunch of different projects on these, connect them in and jack it into this. And that's plenty small for what I'm doing. I tend to prefer boxes like this, on the bench type projects. But anyway, the open-endedness, I appreciate. What I might suggest, a lot went into this. There is room on the edge here. I do like the option, the potential of soldering this down the board. Do the crenellated edges. Bring the pins from the back out to the edges. Move the guts into the middle, maybe. That, well, the back's wide open. These back pins may be in both places, so that can go on the socket or get soldered down.
Shannon, do you have any need for a real-time clock?
That's what I just wrestled putting on here last week on
because we could put an RTC right there. We've got the circuit. Michael's made some little add-on boards in the past for a very nice little chip that uses, is it a 32 kilohertz crystal? And it has a little tiny coin cell that's rechargeable. So as long as you power the thing up every once in a while, it'll never die.
Yeah, I've got that. Looked at the data sheet for it. It's not very accurate. Loses time over.
Oh, don't you have to make some kind of course adjustment once a month or something?
Well, I ended up going with I don't know, the DS3231. JonnyMac had a driver for it, and that's got, well, it's bigger, but is accurate. Anyway, and doesn't need the adjustments.
Yeah, we're using a 500 part per billion.
Oh, right. JonnyMac pointed out that temperature compensation.
Right, on all the P2 edges now. So we could use that to calibrate the real-time clock and make adjustments periodically.
Yeah, real-time clock would be the only other thing that I'd like as standard.
Yeah, I think the RTC
and the smaller mounting, but the horizontal is kind of big as well. On the wrong side. But I end up, in this, that's what I used in this, and end up using the space underneath for other parts. So I kind of double up the value of the space behind this blade, the edge card. Ways I've adapted. Anyway, yeah, I do certainly see the value. And for a while when I started, until I came to terms with this myself, I was preferring the older, some of the other boards that you don't make anymore that have VGA breakouts, mouse inputs and stuff like that on it. But at the same time, now I like the open-ended edge. And that's all I have to say about that.
All right, good.
May I share why I want the P2 stamp?
Yes,
Because this is it's real world.
right.
Our company sells upwards of 1,000 laser taggers, the guns, a year. So it's around about 1,000 P1s we're currently using. We're out of memory. In fact, I do games where we have an SD on the board. And so I'm able to swap out applications. That's the only way we can make everything fit. And, but customers want more, the boss wants more, and we would really like to have the P2. I talked about a project that we're working on called Battle Tower. So all of the constituent elements for a tagger we now have for the P2. Here's our problem. Again, you're a little tiny family-owned company, just like Parallax. We have, let me share, where's the sharing? Share screen. Share. If we, where's the pictures? Oh, shoot. So hopefully this will bring up, can you see an image and it says Edge on LREC right there?
Yep.
So this white outline is our current P1 board. So that's the size of the board. I don't know why it's called LREC. It was before I joined, but that's the P1 board. So here's a P2 in a horizontal socket, and we're out of room because this outside, that's as large as we can grow this board. We don't have a lot of space in our current product. And as you can see, it's just not going to fit on there. But if we had that in an 84-pin PLCC, it would fit, and we have room to spare. So this is what I'm asking for. Now, it's not my idea. As I pointed out, somebody in the forums did this, and my opinion, perhaps not popular, is that if your customers are doing something, you ought to look at it and say, hey, maybe we should do that for them, because it's certainly easier with the amazing production. You guys have great production tools at Parallax. You can put together that PLCC thing really cleanly. What I would caution you, though, as I mentioned in the comment, is honestly, I have no idea why there's this big craziness that, oh, we have to have a gajillion megabytes of RAM on the P. Nobody needs that. There's nobody that is going to take a P2.
I've done it.
Be quiet while I'm speaking, please.
Yeah, I'm just saying sorry because I know why everyone wants the RAM. Everyone wants the RAM because I started the meme. It's just a meme. No one actually needs that much RAM. It's just
nobody needs that much RAM. Nobody's building anything. You're not going to get anybody making silly, gaming consoles that they're selling by the thousands using the P2. But people like John Huffman and me, our companies are building stuff, and we need the basics. So I'm asking on the P2 stamp to go back to the basics. Just have a P2 that only boots from flash, so there's not get rid of that silly SD card and all the switching for that, because that was a bad idea. That anyway, that's gone. Now I could live with just that. Now, since somebody else, again, this was a mention, I tend to use RTCs in a lot of projects, so it would be nice if there was an RTC on the board. Now, unlike what Michael just showed, I wouldn't put a super cap or a battery on the P2. There's probably enough IO pins, so it would take just a VBAT pin from the RTC out of the socket and let the user decide how they're going to power that. And then it's super clean. It's just a P2. And then again, with the option of the RTC, although if you're going to do it, do it. If you're not, don't. But then we can use those two, again, the 2 pins with the LEDs are generally wasted because the interface doesn't always like to play nice with other circuits. So, now you have 2 I2C, you've got the SPI, although the flash is going to use those, so you're really not going to share them with anything else. And you have a really nice, clean, tiny module that I could use. In fact, let me show... Oh, well, this I'll talk about. This is another board. You know, I rarely agree with Ada, but I do on the giant board things, even the one with my name on it. So since we still do a whole bunch of P1 development, this is a board that I made for myself that has the normal, you know, connectors that Micheal came up with that are nice. And as you saw with when Ada was showing video, they're, you know, that's another thing people are doing. We're all building lots of little our own boards that fit on this format, either 8 pins or 16 pins. I've done it. Ray has done it. Stephen Morocco has done a bunch of boards. We're doing those things. So that has become a standard. And in this case, so I do, this is called Silly Add-on. It's very popular with the Badge Life community. There's that quick module Ada pointed out on that other board. It's just 3.3 I2C. That and quick is a marketing thing from SparkFun. Adafruit calls this Stemma, but it's the same thing. It's a JST 1mm connector.
There's a tiny ribbon, right?
Pardon? No, it's a little tiny plug.
Oh.
Yeah, no, it's really easy. And there's lots of, well, especially from SparkFun and Adafruit, they have lots of boards that are using that as a standard connection now, which makes it really kind of nice because, well, for example, John Huffman called me last year sometime and he said, hey, you know, I want to do more of my own coding. You know, can you coach me a bit? And I said, yeah, sure. Let's find a box of generic sensors and IOs from Amazon that we can get for next to nothing, and we'll just go through them. And the one that John found that he liked had the Grove connector on it. It is also very popular. I have a couple of RP2040 boards that use the Grove connectors on it. So all of these are the same signals. In fact, and the I2C is here as well. But then here is you know, it's a P1. The first version of this board, I used just a 40-pin dip socket here, which is cheap, but then you run out of IO pins. And since I'm a big fan of using a logic analyzer when I'm testing things, now I have a board that Stephen Morocco made me that's one of these port extenders. So you get, for each one of these, you get 2 on the outside. So you can connect your board out here and you connect your logic analyzer here. So that makes it nice and easy. But in this case, you can plug in the flip and then you get a female socket on every pin. So you can also connect in things. Now, again, I will liberate good ideas wherever I find them. And that was, I have an RP2040 board that uses this kind of arrangement. So this is another thing that makes it very easy. I heard somebody, I don't know, maybe I misunderstood, but it sounded like a knock towards the Lego or Lincoln Log approach, but I actually quite like that. You know, again, when Micheal made the P2 breadboard, again, the one that's got my name on it, I like these connectors. And I've made about 20 different boards for our company so that we can very quickly prototype circuits together and then work on the code. And so, you know, doing things, you know, this is stupidly simple. You know, this is takes almost no energy to put together, and I have boards just waiting to be soldered, but it allows me to be very, very flexible. You know, in the other side, let me go to this, on Battle Tower. So here's our Battle Tower board. It's 4 by 3 inches. Because see, there's a lot of space for the socket, which we've talked about, but even more so is because you have the socket being gripped. Here, I'll go ahead and put this in 3D. We had a case where a customer knocked one down, and the edge flew out of the socket. And because of the metal pins, it happened to hit some exposed metal pins on the board, and it killed the power supply. The smoke was coming out of it. It was a big mess. Luckily, it was an off-board power supply that died, and we were able to repair it in 2 minutes. But, so you'll see what we're doing for the next version is that we've had to create, and we're going to 3D print and put essentially a horseshoe over the whole rig to hold the, sorry, there's a few parts, and DipTrace is not really fast at doing 3D drawings, to put that all in place. But if that was an 84-pin PLCC, it'd be right in the middle of the board. It would take about the same amount of space as far as square millimeters, if you look at it that way in the board, but it would be clean, it would be flat and smaller, and it'd be clean to use. I like the edge, but you know, something tells me is that because Parallax is so invested in the microbit, those sockets were around and somebody said, oh, hey, let's just do it in that format. And I don't think it's an ideal for those of us that are developing products around the P2. So you see, this is what we have to do, is put this on there to make sure that if somebody drops something, or, you know, I mean, God knows Amazon and everybody else who ships, just, they're not very tidy with things. So you see, I have a lot of space on this board. I'm not, you know, I'm not skilled like Micheal at doing PCB layout, so I do it really, really simply. But I have a version of this board that works, so I know it does work. It'd just be nicer, I think, if we had that PLCC 84 right in the middle instead of this big thing.
Yeah.
So anyway,
Well, I
that's,
like the edge. I do. I'd also buy these stamp size ones too.
yeah,
Another problem with the
us,
edge
like I
connector
said,
is
with-
that. Oh, sorry.
I'm sorry.
I can.
John, can I just ask you one thing while you've got that photo up? Sorry to interrupt your flow.
This one?
Oh, sorry, not that one. The previous, the one actually that had the P1 outline. Yeah, one back more. With the edge superimposed on it. Yeah, that's the one. So just looking at that, how many millimeters would you say the edge is overhanging the edge of the PCB there?
It's about 5.
Yeah, so if we reduce the socket by at least 5 in height, would that then allow you to use an edge? Well, we're shooting for closer to 10, but you know, if it was at least 5 less, would that allow you to use the edge in that application?
I don't know, but that still doesn't negate doesn't eliminate the problem of all the mass being out here and the connections there and having the thing come out of the socket without me creating some kind of restraint.
Mind you, even if there's
well, if you
like a, even if it's
the
just sitting there
idea is with the
upright,
right angle connector,
it stops working.
Oh, so what was that? So the idea is with the right angle connector that you can then use a simple standoff straight through one of those 3 holes.
I guess we could.
And that was how it was originally intended.
Micheal, so you're not talking, sorry to interrupt, but you're not talking, you're actually reducing the depth of the connector in addition to the amount of surface material that's connecting to the board?
Yeah, I mean, look at the disparity, like what's needed versus what we have.
Okay, so you're not reducing the connection space, you're reducing the connector shell.
Everything, yeah, like collapsing the volume of that thing down to minimum just to make it work. And then we could put tabs through those holes.
Well, question, mechanically, I don't have it in my mind then how you're gaining, if you look at JonnyMac's picture here, from the top of the edge of the connector where the pins are visible to the edge of the edge board at the bottom, I don't understand how you're shortening that depth by shortening the shell of the connector.
Because at the moment the black so the part that the edge module is actually going into, forget how it's mounted to the PCB, whether it's vertical or right angle, that's irrelevant at this stage. That actual block that the edge module goes into is 15 millimeters wide, but the edge socket itself is 5 millimeters wide. I'm just rounding up to the nearest to make the point. So we can reduce potentially the length of, or the, you know, so that edge module in theory with the low profile socket would be, you know, up to 10 millimeters further inwards.
Well, I just pulled the edge out of my live battle tower board, and it looks like the engagement here is about 6 millimeters.
Yeah, I mean the engagement would move as well with that.
Yeah, of course.
So
of course.
Yeah. I mean, it's an awful lot of plastic. And to be fair, they do exist. The later versions of the microbit socket are low profile ones available. Just unfortunately, they went to single-sided contacts, so we couldn't just use, one of those off the bat. But we're working on getting a double-sided version.
Well, here's from a commercial standpoint. We can, again, small company, we can do one of two things. We have to do both ultimately, but we either are able to put the P2 into our current tagger, or we have to wait and then invest a couple $100,000 in tooling to create a new tagger body so we can fit a P2 into it.
Right.
What's
Now-
actually preventing you from just
but what I'm
soldering the
saying is if you
P2 straight to the board?
Nothing. And that's probably what I'll end up doing.
You don't
I
need
wanna say
like crazy
something.
6-layer stuff if you're not doing overclocking or like whatever the.
Yeah, we're not. I
Same
don't
thing
run
is-
anything faster than 200 megahertz.
Yeah, that will work. That even the really crap boards do that.
I think Ray's first P2 board that he made was just double-sided. I think Clouseau's board too. I think that's double-sided.
Yeah, you can certainly run it with just double-sided and like the worst regulator known to Mauser. Like
Well,
just
again, we sell 1,000 products a year. We're not going to use crap parts. We will select the best parts we can. It's the
Well, the
difference
best parts
between you and me.
requires
I
having the,
actually have to
like,
sell stuff for a living.
16s.
Hey, I
If you
wanna
take the
say
best part,
something.
you
When
need
do
to
I
like
get
the
to talk?
16 different regulators because each pin
Hold
group
on.
kind of needs its own.
I wanted to say something. When do I get to talk?
It's your company.
Yeah.
Say
Never.
talk anytime you want.
He's
All
been
right,
waiting.
thank you. I'm driving, so I had a lot of thoughts running through my head, but on the subject of a smaller P1 or P2 module, look, I can suck the fun out of the room for engineers that have dreams. All right, this is totally a business decision for customers that have businesses. For us, it's like the 3 C's of business. Chip hates me for these words: customer, concepts, and capital. We can't make this stuff for free. It has to have volume, show me the money, and the design has to be something that people need who are making stuff. So that means initially, it doesn't have anything like RAM. It doesn't have micro SD sockets. It doesn't have USB ports. It's super small. It's cheap. It's different than the P2 Edge. So it doesn't steal the P2 Edge. It's super minimal. That's what the P2 Edge actually started as before it grew. So my hope in sharing that Michael shared was, if you're a customer that's making something and you really need a small application and you can save money by having us pack all the key parts on a super small module for you, tell us who you are and show us. Tell us about your need, because we could throw you in the pot with Elite and maybe we could make something like this, but we aren't going to make it based on what we want it to be. It's got to be what our customers want it to be. The stakes are high. I mean, it costs us a lot to get these things going.
I know that John Huffman would use them as well on his products. He has the same problems we do. He has to strap them down. And then, in John's case, and I know his stuff well because I coded it for him, he's got the remote control end where the operator has joysticks and knobs and buttons, where he's controlling the camera platform. And then on the platform side, which he calls the remote head, that's just a small box with lots of controls coming out of it. And so he's using this kind of setup, but it's not super ideal for him. He'd rather have it a little cleaner. So I know John and I both would be using that. And I think it's one of those, since cliches are cliches because something is true so often, but what was the old baseball movie that said, if you build it, they will come. And I think, to your point, Ken, so remember I started with your company with the basic stamp 1. I want the P2 version of the basic stamp 1. I just want it super clean, simple, nothing fancy. I will take a RTC if Michael puts that on the castellated board. If he doesn't, I'll put my own on there. But I think that would be a useful thing to have. Although, like I said, I could live without that. If it's pure cost to just keep things stupidly simple, then you'd have P0 through P56 as user IO. The next 4 pins would be the flash, and the top 2 pins would be the programming. And Bob's your uncle. Build anything you want out of it, including Chip's future standalone computer. Put that in the middle of the board, and then put the PS RAM right next to that castellated socket. Or in that case, that'd probably be one would be better just to solder the whole thing. As Ada was just saying, why don't you solder the P2 on the board? Part of it is, and maybe it's me, not trying. I solder P1s on boards all the time. I haven't yet tried to solder a P2 in my easy bake reflow oven. Which is to say, it's a toaster oven that
Right.
doesn't get
It's
food.
so much more complicated because of the bypass and
Yeah,
other
exactly. There's
requirements.
lots of caps and all of those things. Oh, like I said, Ray has done it well. Ray Allen and Ray Roddick, was that his name? Clouseau. I haven't seen him around in a while, but he did that board with the VGA connector on it and all those things. So it has been done, but it would be really nice from a prototyping and a building standpoint. If I, see, I can do the layouts, like this, this stuff, I don't have any trouble doing because that's all lots of room, easy to deal with, no signal issues, nothing, So if you'll do the hard part for me, I'll do the rest. And I think a lot of developers would tend to think that way.
Thanks,
Mhm.
Johnny.
So we can build real products and sell them.
This is important. Like the economics of these things, which nobody's interested, probably but me. But let's say it costs you $30,000 to bring a new module like this up on production after you've done prototyping, NRE, fixtures, stencils, pick and place setup time, some initial inventory purchasing, and it does. You guys can all do the math. Then you want to get that back over 2 to 3 years, and you have an average gross profit of $15 per module. How many do you have to sell in 2 years to do this?
Was that same calculation used when adding RAM to the module?
Yes. So then you take,
And
if
then did it
90%
pay it?
of our customers need RAM, yeah, but I mean, if 90% of them don't, then we just burden the product with another several dollars of cost.
Exactly.
And that usefulness is thrown away and we're paying for it. And their expectation is still cheap, cheap, cheap. Everything's getting cheaper and more capable. That's the trend. So we can't afford to put anything on there except what 90% of the volume users would need. So if you're an elite laser tag manufacturer, or you are a electronics guy like John Huffman with the camera controllers, or somebody else making something, tell us who you are. Identify yourself, please, and let us know if we could help you with this concept. And we can know your requirements.
Yeah, I think I mentioned this in our email this morning. It's not a commercial thing, but a guy like Rick, he has some downtime, and I said, hey, time to learn the P2, because he's doing really complicated animatronics for movies, and he could really benefit from the P2. And it came down to, I can't fit that into the head of a robot that I've got on set with all the other stuff. But
yeah,
I think
he liked the Prop Mini.
Yeah,
for that reason.
but that castellate, that PLC C84 socket's not much bigger than a P2 Mini, P1 Mini rather. And with all the IOs and the benefits, it's funny, Rick will call frequently, or he said, hey, how do I do this on the P1? Said, you can't do it on the P2. It's built in. I mean, that's my frustration, is the P2 is the best chip, I think, out there, but there's not enough in the way of support outside of this small group where we support each other to get the rest of the world going. I think a smaller version, hopefully would impact cost in a positive way for the end user and not hurt Parallax. That might help too. But every time I see somebody talking about, oh, look, my RP 2040 has 2 cores, I'm going to say, shut up, I got 8 cores and they're much easier to use.
Well, the recipe for this thing would be pretty simple then. It would just be the voltage regulators, the clock, the flash, forget dip switches, and an HDMI socket, right? Because we don't want it mixed on with those pins anyway.
HDMI socket.
What's I mean USD, sorry.
No.
Yeah, no USD socket necessary.
I told you,
so-
JonnyMac can suck the fun out of the room with me.
No, but Chip understands. Says, look, we're not.
Yeah.
You know, I mean, technically, for the 2 people that use boot from SD, that wouldn't work, but it would save
You
room
can
because you have
put
to be
an
able to
SD
select
bootloader
that.
in the flash.
Exactly,
You
yeah.
can just do that.
Exactly. Yeah, there's a way around it. That's not a hindrance.
Yeah.
John,
So
could
make
you
it just
stop?
again. Think. If I was building a basic stamp 1 with the P2, how would I do it? And I was going to put it in that castellated format.
Yeah, well, I'm looking at it. It's easy. So we would just have the voltage regulation, the clock source, the voltage, well, the caps around the chip, and the flash chip, and that would be it.
Yeah.
No dip switches, no other connectors,
Nope.
only the castellated edges.
Right. There you
And
can stick
John-
into a PLC 84. PLC.
John, could you stop sharing for me just for a moment?
Oh yeah,
please?
sure. Sorry, Michael.
And one thing that I would like to add is if we can use, of course, minimal design, also simple, good quality yet simple parts that we can get easy drop-in replacements. There's a lot of disruption in the supply chain. Right now it's going to get worse. So we don't want to keep revising and redesigning this board all the time because that gets expensive. That means we cannot sell it as lower cost as we could if we just design it once and it stays for a long time. To survive for a long time, we need parts that we can replace and as little parts as we can, and parts that are common in the way that, okay, this company doesn't make the part anymore, or we cannot get it, we use this other part that drops in.
Michael, would it be possible on this design that you're showing, the P2 Industrial, to bring in an external 3.3 volt power supply and distribute that around, and that way you'd only have to have the 1.8 on this module? Or is that not a good idea?
You could. It would rely on the customer having a really good power supply.
Okay, so that's all right.
Well,
Having
there's a really good reason for us actually distributing the power this way. Well,
Okay.
there are 2 reasons. Now, they might not be valid in your project, so it's worth mentioning them one of them is heat distribution.
Okay.
Because, with this with the Edge module, this is even smaller, but with the Edge module, I really had to be creative in ways I was distributing the heat. The other reason is actually it was cheaper to use these tiny regulators than it was to think about filtering, and where we want to have groups of pins used possibly for analog, possibly for digital.
Okay.
Say no more. So
Yeah.
this was a convenient way of allowing that partitioning without having to go overkill with.
And so we got to feed them like 3.5 volts, and we regulate down to 3.3 or so. I know they're low dropout regulators, but it makes for super quiet analog on pins.
Okay. Yeah, that's why I asked. I was just getting to the point of like, hey, how simple can we make it? And that was too far. So would this board you're showing, Michael, would this be like 5 volt input to this, and then it regulates down everything else? Excellent.
Right.
That would be excellent.
Yeah, I think 5 volt in would be just fine.
It's what we had on the original Edge module, if you might agree.
Yeah.
I made it much simpler, and unfortunately, lots of people were very upset because they kept plugging the wrong wire in and blaming the module. And,
I broke one, so yeah, I did that too.
Yeah, and so that then meant a whole, a second regulator, which
there'd be a little less chance here because this is going into a PLCC socket, not, it wasn't on a dev board that had a 2.1 millimeter barrel connector where people have, like me, 12 volt power supplies that they end up plugging in.
Yeah,
this would be fantastic.
Absolutely. I mean, this is sort of this is almost the simplest it could be, keeping the high precision clock, keeping just the 16 meg flash, well, as you can see, and the using a miniature switching regulator, which I don't know, there might be some people out there that have a version of the Edge module with this very compact regulator on. It didn't last long because COVID pushed the part out of we had to go from Rev C to Rev D after one build because the regulators became non-available for 2 years. But they're back now. And that's it. And obviously the 3.3 volt LDOs on all but on most of the corners. Obviously, with a bit more time, I would tighten things up and make it more,
of course, no,
compact and bijou, and probably get. And we could most likely have an RTC on there as well because they're pretty low cost. The battery is actually the big cost of those RTCs. So we could
just
choose
bring
a
it out
use
to a
on
pinch.
8. Yeah, we could put a use on 8, which would sit nicely next to the flash chip.
Yeah,
same part. Where would we run that in? I think it'd be IT squared, wouldn't it? So we could just
so
have
I'd put it on 55 and 56. So again, that top end, because I kind of do that in my designs now. All of my designs are I kind of sandbox 63 down to 55. I'm not using those pins in an application, for right now. So it would be the same kind of thing. But now you'd say, okay, 55 and 56 or a 3.3 volt I2C bus.
Yeah. And would you see it being shared? So if there was RTC on 55, 56, would you also see those pins available externally?
Yes, because then because now you have a bus. And the nice thing about RTCs is they have their own part number, but they don't have an address in there. So you're only going to have one. And now that just saves you from having to put one on your board. Although, and I'm sorry, I forget the gentleman who was speaking earlier mentioned my DS3231 driver. That would be, I don't know, you might run into a thing where, because the RTCs tend to use the same slave ID and you can only have one. So that might, but those are going to be the non-normal problems. I mean, that's getting deep into the dust bunnies in the corners that probably none of us are going to see. But having I2C, again, it's a very common thing. And, as I was saying earlier, when I showed my P1 eval board thing that I'm doing for the flip, we put a quick connector on there. I don't know if you saw it when I had the tower board, the battle tower board, but on the north side of the board, there was a quick connector and a JST connector, because that board's going to go into 2 different products. And one of those products needs an I2C display. And since we were putting the JST connector on there, we just said, let's put a quick connector on there anyway, because there are just lots and lots and lots of very low cost sensors and accessories that you can get with that format. So just, for the small price, I think it's about 50 cents for, when I'm doing onesie stuff, to put that on there. It just makes it really easy to be able to add things. That's, again, so all of my dev boards have them. In fact, at the event, I'm going to bring, that board I showed and other boards and all of my little tchotchke boards that I've built for us to do dev. In almost every board that I made, if I had 2 extra pins, I went ahead and put a quick socket on it, just so that I could always, if I'm doing something, I could plug in a little, I2C OLED or something like that. It's just a very, very convenient format that seems to be accepted. SparkFun has got bunches of parts and bunches of boards. Adafruit does too. They call it Stemma, not Quick.
I'll second the request for 5657, the LED pins. Putting an RTC on that, yes. I2C, that would be dynamite use for that.
I thought I came late.
But if we made such, oh, sorry. Go ahead, Ray.
Oh, I was just going to say, this looks a lot like, I heard somebody said PLCC, so I guess is this going to be similar to stamp?
Yeah, we are talking about a P2 stamp.
Oh, okay.
Although your board got a nice showing, although at one point in that presentation you were referred to as a clown, which I'm not sure why. But your new P2 platform looks really good.
The clown thing was regards to like the HDMI connector on this breakout board. It's just like not soldered down. Like where can I see? But there we go. This is just not soldered. Like this is just flapping on by the SMD contacts.
Oh yeah, that's a prototype.
Yeah. I mean, I
Ray,
can fix that, but
Ray, is that a 2 or a 4 layer board?
the main board or the breakout?
I was
But,
asking Ray
okay.
about the P2, his new P2 platform.
Okay. Well, I really wanted to hear about this stamp like board because I think that'd be nice. But okay, we can talk about this one too. This is yeah, it's 4 layers. And I've been, you know, if you read my forum thing, I've been struggling for years now, trying to get, you know, high speed with a 4 layer board. And yeah, I finally got it with this thing by adding in the option to increase the core voltage. And now I think it can rival the Edge in terms of top frequency. So that's good. And yeah, it's a 4 layer board, and the accessories are like 2 layer boards, so they're cheaper. Yeah. Well, my stamps, I got this. I hope you guys can figure out how to make it cheaper, because the boards that I got were 8 layers and had that special edge, and they're like $14 each. That's kind of the struggle with that kind of thing.
Okay, the special edge was for the castellated pins that then rub against the socket pins, right?
Yeah, yeah.
So yeah, because I was just thinking, I'm looking at PLCC84 sockets, and you know, the chips that normally plug into those things have like very stout leads that are not gonna, like, some little amount of 1 mil of metal is not gonna rub off, and then it's gonna be an open circuit. So is there some special process for making, like for PCB manufacturers, that they can put enough copper on those castellated edge kind of recesses?
Yeah, that's the edge plating.
And it's expensive because you have to pay for the additional plating.
Okay, so there is plating involved. Yeah, because otherwise that would rub off and it'd be game over.
Yeah, it's edge plating, and it's yeah, and like the first company I went to make the boards, the guy that designed this thing, he sent me to ALP, I forget the name of the place, but they said they can't make it because they needed to have electrical connections on the edges that you're plating.
Oh, to do
and
the
there's nothing there. And there was not. Well, no. Did they need electrical? No, no. They just needed a way to. I forget that. I think they needed a way to grab it on the edges they wanted to plate, and there was nothing there to grab on this thing. So, but his other company, who did I get with? Gold Phoenix. They did it. It looks like. I still don't know if they work yet, but it looks like they did it. But yeah, if you guys can make something like that, that'd be great. Because you know.
Or if any
Well, of course,
connector, there's
if
like
we made some.
I've been trying to bring this issue up for like 5 times, and every time someone talks over it, it's amazing.
Well, go ahead. You want to say something?
With the P2 edge, one of the problems with it is actually that the socket develops issues over time. Like I've had this P2 edge that I have. This has pretty much been sitting in there. It's maybe been unplugged like 5 times or something. And the rest of the time it's just sitting perfectly upright. And this has contact issues. Like if it gets a bit jiggled, all the pins go weird. And like it restarts the program and stuff like that.
You know what? That could be happening on the power pins, because where there's high current flowing, you tend to get opens. But I bet the signal pins are probably fine, but it could have something to do with the contacts that have to do with the power delivery.
I think I had just one of the signal pins go out at one point. I had to just pull it out and plug it back in.
Okay.
I haven't tried. I don't use the PLCC stuff often enough, but when you like repair an old computer, one of the first like troubleshooting steps is just pull out all the socket chips and put them back in. Like I think there's just a general problem with putting these things in sockets, which the socket just sort of stops working.
Bit of corrosion.
Yeah, where current flows, things tend to form opens.
Mike, does that one have gold contacts? I don't remember. Edge connector, is it gold?
Yeah.
It is gold? Huh, should be okay
Yeah.
then.
It's like 10
Gold flash.
micrometer plating, or you know how many micrometer?
I can't remember. It's
But
but
it's
it
the
but it
same
was
connector.
but it does have additional plating for the
Yeah,
Same
and there are,
connector is the BBC micro thing, right? So you'd think that would be good.
yeah.
there is a wear spot midway up where I can see the connector was contacting this edge row. And so I could see it wearing down the plating and the metal at like points that are, you know, 1/4 by 1/4 millimeter. They're very tiny. But that's where the wear is occurring. I wish my document camera would run, but I don't know why it's not working. But otherwise, you could see this clearly. So Michael, I wonder what that means for us if if we make a PLCC 84, we have possible issues with the side plating on those pins. But if in applications where the customer just solders it into position on a motherboard, that won't really matter.
Yeah, and,
Oh, yeah.
you know, if you think about such a module, then of course the next question is, what should be on the demo breakout board that comes with it? Because in itself it's useless. So I suppose it would need a small demo breakout board with a USB-C for power and programming.
Yeah, which means it would need a prop
and some headers, I guess.
What if you took the P2 eval and ripped off all the unnecessary stuff and stuck a socket right in the middle?
Yeah, job done.
Because that format I really like. Again, I always use that, and then your 2x6 expansion header idea. I use that all the time, which is why I showed that P1 version that I made for myself. Which I think, if Parallax wants to make that, knock yourself out. I think it would be helpful to get more people working with the P1. And, the important thing, and it's probably obvious, but I'll state it anyway, our little company, we're going to be doing lots of products with both. An interesting thing with the way our next generation product is working is all those P2 sales that we're going to be doing, that's not a conversion of P1 sales. We will be buying as many P1s as we are today. So I like having the ability to do really quick prototyping with the P1, and the Flip is really the only viable P1, that's altogether easy to use. So I did it, so thank you for the good idea, Michael. I liberated it and made it a P1.
So in terms of the PLC type board, so the guy that designed the stamp, he came up with a little breakout, which I kind of like because it's like dirt cheap and there's like you can make it for basically zero. And I guess it has some weird USB connector, but I guess I put a USB-C for power, and then I just do what he did and put on a prop plug connectors to make it dirt cheap. Because you do need some way to, you can't just sell this chip because you can't really do anything with it. So yeah, you need some kind of little thing for it.
Yeah, you have to have a pack with it. Yeah.
It would be technically possible to have it. So if we put some permanent code on the flash chip, which treats 62 and 63, so we always boot. I mean, there's a mode here where we can always boot from the flash, right, and not do the serial. Well, we could, with some software, treat 62 and 63 as a USB pair, or USB 1.0, but we would have to spoof the personality of the what do we call it, FTDI chip, right, and make it look like a serial port to a host system.
There's code for this on the forum already.
I like that.
Wait, Ada, what'd you say?
There's code for this on the forum already. I just said it very quietly.
Oh, okay, all right. So that would kind of simplify things, but the trouble with HDMI is there is kind of a lengthy
USB, you mean?
like what do they call when you plug in and you do the initial
Negotiation.
negotiation, which might kind of like bankrupt the timing a bit, you know, so you can't have fast startup unless we put some override switch to bypass it.
Yeah,
I
but
think you
the
can
whole
pretty
goal
easily
is to
figure out if
simplify
it's
things.
What? Say those things again. You got blurred together.
well, I'll say it first. You can probably pretty easily detect if something's just plugged in into the USB port. I
Yeah.
think it's easy from the host side. I don't know how it's from the device side.
A quick question, Michael. Are you Von Sabras in the forum? I'm guessing that's true, but I don't know. I don't know that.
Yeah, that's true.
Oh, okay.
So Chip, with your idea, you also suffer the risk of overwriting that flash, though, right?
Exactly.
Yeah. There's like a point. There could be like a problem returning to, like if it gets corrupted, you'd have to somehow use something like a prop plug to reprogram it, and you might have to have some kind of switch that you could open or a jumper to enable you to do that.
Don't these flash
That
chips
sounds like a
have like a?
complication.
Don't these flash chips have like a write protected area that you can use?
Yeah, the trouble is though that do we really want to once and for all write it and then never get it back?
Oh,
No, and you don't really want to think about this on the module anyway. Just have it unencumbered straight out.
Yeah. Okay,
Usually
so
fine.
right now, and it is something we
Don't get rid of one god awful complicated feature and replace it with another one.
thank you.
well, yeah, the this FTDI stuff is not so simple, but you know, we're not really married to FTDI. We just have been using their chips. I mean, at this point in time, there might be better chips out there that even have better drivers that would enable faster debug. You know, I don't know.
Probably not a speed, but more universally acceptable.
On that old P2D2 board, which yes, I also have one laying around, but I think it's like not populated. Anyways, that had like a really wacky thing that I think did both the serial and the clock generator, something like that. It's a bizarre thing.
That was since discontinued though. That was I think it was a silent. Oh no, CP. Anyway,
It's a CP 102.
No, it wasn't. But it was there. It was a UF. I'm looking up because there's some up there somewhere. It was a small microcontroller that had a USB functionality, and it has been since discontinued. But the firmware that they wrote, the two guys on the forum, JMG was involved. It emulated the CP that you mentioned.
Oh, so it got around.
It was the same manufacturer.
Yeah, well, I think nobody open sources what happens on the. You have a host, and what's the other thing called? Device.
Device, yeah.
No, it's never open what happens on the device side for these serial transceivers, right? That's always proprietary.
There is some chip, what is it, AT Tiny or something like that you can like comes in a form where you can just stick it into a USB port and it can talk, but it shows up weird. You know, personally, I really like the new FTDI, the FT231X. It seems like it's been flawless for me, so I don't know. I wouldn't change
it. FT231X. Is that what you said?
Yeah, a version that supports USB-C.
Oh, it does. Oh,
yeah.
So we could go like super high debug rates.
Yeah.
Wow, that's interesting. Yeah, okay, so this is like 480 megabits per second, which means it'll probably do 480 megabytes per second, or 48 megabytes per second, right?
It says 3 megabaud here.
Oh, okay, 3 megabaud. Yeah, I see that. Well, it's $2. It's $1.77 at 500 pieces, so it's cheap.
But then why are you looking at the chip? You're talking about what to do as a carrier board for when you ship the stand?
Yeah, because we need some way to connect it back to the PC for loading.
And why wouldn't you just still use the prop plugs?
Well, they're based on these kinds of chips. But I mean, it would be nice, see if we put a USB-C connector on, I believe we can get enough power to run the board and do the comms that we need for downloading. Is that right, Michael?
Yeah, and I think it would be nice to make it a simpler to get started solution, to move the barrier of entry towards the simpler end of the scale rather than make it more complicated. So I think if we were going to do it, I think a small carrier, because in this case, the carrier really would be something that someone would buy one or two of, maybe in a development setting. They wouldn't buy one. They wouldn't need to buy one per board. So it wouldn't matter so much that it's a little more expensive. I think it would be more important that it's easier to use. And so I think if we had a carrier that had USB-C to provide a decent stout power supply and programming, yeah, we'd probably just whack an FTDI, the new version that supports USB-C on there, possibly something else. But all our software is used to running FTDI, so it might be the simplest way in. But we'll see. We have to look at what's out there.
And we've had two competing suggestions so far. One was something that looks like your current P2 eval board with all the headers on it, and the other one was one without headers. What's the thinking there?
Yeah, we'll see.
Okay.
I mean, but a breakout board like that is probably going to be fairly low cost anyway. I mean, I think you'd have to have one that's ready to go, plug in a USB-B cable, and it just works, because we have to remove that barrier to entry. We have to, it's got to be plug it in and get started working.
But then without headers, you can't attach peripherals, right? So you
could possibly, well, yeah. I mean, you'd possibly have. I mean, if it has the 12-pin array headers on there, then
I really didn't want to talk today. Oh, sorry.
But yeah, I mean, it could have a couple of other sockets on there to allow you to get other stuff into it quite easily, like a Quick or something. But it would be nice, really, if it. Okay, I'll keep those thoughts to myself. Anyway, yeah, it should just be a simple board that gives you access to all the IOs in a standard way, probably 0.1 inch pitch, powered by USB, because that's kind of all you need, really, isn't it?
Yeah.
And anything else would be a different board. If someone wanted to make a board that's suitable for guys getting into video, or someone wanted to make a board that's suitable for other purposes, then they would be different breakout boards that other people, I think, in the community would make. I think we just need to make that base socket to 0.1 inch headers, possibly a Quick or something, but essentially just a simple thing ready to go with the nice clips on for your scope probe.
That FT. Oh, go ahead.
I was going to say, Parallax has the advantage of having that. I think they have this wave soldering machine that can do these headers automatically.
Yeah.
So that makes it kind of a lot, kind of a no-brainer to do that.
Yeah. This FT231X is actually just a full speed 12 megabit per second device. I wonder, Charles, do you know, or Ray, do you know if they make any kind of serial interface like UART that runs at much higher rates, like using USB 2.0?
Yeah, I think they have some stuff. So they have some new stuff. So, but I'm really happy with FT231X right now. So I don't think I'd change. But that's
there are faster USB interface thingies, but they usually don't just have the single UART interface.
There is a new feature. Oh, sorry, Joey. Sorry.
Like, I don't think anyone actually does more than like 2 or 3 megabaud.
Right, because that's historically not what serial was used
They do
for.
have ones that have like a parallel interface that you just clock stuff into.
Yeah, I've seen some USB 2.0 that'll move 48 megabytes per second.
I've seen some 3.0 that can do that. They can do just absurd rates. I was thinking about that because the landscape of like video capture is extremely dire.
Right.
You get cheap ones that will just give you compressed video. You get the expensive ones that give you uncompressed video, but the drivers are complete hot ass. I've shown you the data path card before. Just driver is just so ass, it makes the computer crash all the time. Also, these cost like $1,000 new or something like that.
Yeah, I just want to mention one thing about the FT231X. I guess it's a new kind of a new feature that they added in the newer version. It has this battery charge detection feature where if it's connected to a battery charger, it'll turn on a pin that'll allow you to draw large amounts of current. And so I think by default now with USB-C you can actually get 800 milliamps from some connectors if it's USB 3, if you're connected to a USB 3 port, but you can actually get more than that. I think it's like 2 amps if you get this battery charge.
Yeah, at 5 volts, right? So that's like 10 watts. Plenty.
Yeah.
We only need like 2 watts to run full blast.
Yeah, but I mean, if it's like something with a battery, you'd be able to charge it quickly from the port.
Mm-hmm.
And if you were powering other things on the breakout board, it's not just the propeller. You've got peripherals and whatnot that you might be battery powering, wanting to run through that.
I mean, the single regular USB port that eventually I figured out that if I have that as a specific USB port on my PC that just is really happy delivering comical amounts of current. And it's actually running a P2 board pretty well with like the one with the fan that I've shown. Right now the fan isn't making horrible grinding noises, so that's good. Yeah, but that all runs off a regular USB port. You don't even need a charger for that. So you'd only need that much current if you're like, I don't know, running something that needs a lot of current. That's a stupid thing to say, but
yeah, I run I have some things that run like 7-inch displays, 10-inch displays, and those things eat huge amounts of backlight current. So
yeah, those need a lot.
There's another thing, from the stamp, if you might want to think about copying is the little through holes on each pin. So if you don't want to use the PLC socket, you can actually just
put a
mount it, use headers on it. I think it's like 0.5 millimeter headers, so they're like tiny little headers. But that'd be like a cheap way to mount it to a board if you didn't want to do the socket. Maybe it's more, permanent.
Also, speaking of LCDs, you still haven't sent me the documentation for that one you've sent me. It's just sitting in a bag now. I don't know what this is.
Oh, okay. Yeah, I'll send you an email about that. It's a New Haven board. It says it's an old New Haven display. It says the part number in the back, but yeah, I have some code that I'll send you that.
Oh, so that's just the 480 by 272 stuff, right?
Yeah, it's an old display, but I have a bunch of them, so.
Yeah, it's just that those are the ones that I can't really use that well because all my stuff just kind of expects to run at like NTSC scan frequencies. There's stuff that could be made to work, like the funny 3D rendering stuff that pretty much just renders entire frames that can do any scan rates at once.
Yeah, I should send you I was contemplating. I didn't do it, but that there's also there's a 4.3-inch display from New Haven that's VGA resolution that can work on that board. So that'd be interesting to see if it could work with the emulators. But
Yeah, if it's 640 by 480, that can usually be made to work. But I don't know how you do that over 16 pins. That's kind of, you kind of end up having to putz around with the pixels, and that's when it becomes painful.
yeah, that board I sent you, it uses a trick I talked about before. I think it's posted on the forum. That uses a latching chip to latch 8 bits. Yeah, so it's 16-bit resolution, and that chip latches 8 bits, and then the other 8 bits come from the P2. So it has, yeah. So there's a trick involved with the chip.
And where do
yeah.
the sync signals come then?
Yeah,
They're
from the
just-
P2. Yeah.
They're just straight through, right?
Yeah. So
Can that be made to work? I don't know.
It works. I've tested it, but that's with the eval P2 eval board and the edge type boards. There's kind of a limitation with just trying to use 2 headers to interface a 24-bit LCD. So it's just
Yeah, that's
something's got
not
to give.
working. I mean, for the small ones, they usually just have this 8-bit mode or 6-bit mode built in. I think I've posted about that on the forum extensively. But that only works for the small resolution ones, because for the big resolution ones, you just have so many pixels, you need to update them really fast, so you can't do all the funny business with converting them.
Yeah, no, I have this thing works in 16-bit mode, and it can drive a VGA resolution display from New Haven.
Yeah,
so
but you
it
can't
uses
really do that very well with just like can you really do that at like the maximum scan frequency and also while doing the other things in the driver cog?
Yeah, it does like 60 hertz, so that's like where these things operate.
Yeah, that's like because I've kind of run into big problem sort of doing that for the 320 by 240 ones. It takes quite a lot of cycles too. Because you need to grab what the 24-bit data that's in memory. You sort of have to shuffle it around a bit, and then you have to send it into the streamer so that it streams out the individual bytes.
Yeah, I'm really liking Chip's PS RAM driver in 16-bit per pixel mode. So I like, that's why this and with the this board, that display board, it can do the New Haven. It can drive the New Haven VGA resolution 4.3-inch display at 60 hertz, or actually it's like 58 hertz at 300 megahertz. So it's like it is a challenge to get the 60 hertz, but it just does it just enough with if you're okay with running at 300 megahertz.
Yeah, that's the sort of thing that, well, if I had one, I could probably figure it out.
Yeah,
But,
no, I have the code.
well, if
for it.
it's 16-bit, then you'd have to do a double shuffle, because your data is coming in, and then you have to convert it to 16-bit. But if it's not, but if you like doing a paletted screen, then you have to read the palette and then convert that to 16-bit, or convert the palette to 16-bit when you're loading it. Which is...
No, it's coming from the data comes from the PS RAM driver. It just fills up a buffer.
No, I'm thinking about the different kinds of video modes that different sort of software uses. So like all like the 3D rendering demo that I did uses 16-bit from PS RAM. That's the same. All the emulators that you do real-time rendered 32-bit, so 24-bit color plus the padding, and it's just rendered in real time. And then I've recently done some other stuff, and that uses 8-bit indexed colors, which are also rendered in real time.
Okay, I see what you're saying. Getting it to work with the emulator might be impossible. Yeah.
Yeah,
so that could be.
Just getting all the different applications to work on something like that. Yeah.
Hey guys, I'm seeing here there's a part from FTDI called the FT234XD. It's only 12 pins. It's like a standard part. It has the CTS and RTS, so we can do the reset. So it's got TX, it's just got the bare necessities of what we need. Doesn't need any external parts. It's like the cheapest part they sell, actually. And it's like 3 by 3 millimeters or something. It's super tiny. Do you have any experience with that, Ray? The FT234XD?
I may have seen it, but usually if I see something that doesn't have pins sticking out of it, I try to avoid it.
Oh, okay. All right. Yeah. Yeah, this is a DFN12 package. But this looks like it does exactly what we need. And it'll go 3 megabaud, but I think it said it has a 12 megabit, or no, a 512 byte buffer inside for smoothing out things. But I don't know if the chips we use don't already have that.
That's probably worth looking at. I know they face pressure from Chinese competition, so they're probably trying to make it as cheap as possible and as small as possible.
It doesn't require any external filtering or anything. You just hook it up and you got a UART. It's like as simple as it could possibly be. So I've written this down, Michael. It's FT234XD. That looks like a cool part to use. I mean, that's so tiny and simple, and it's like it's the cheapest part they sell. It's like 8 cents less than the 231X, but it looks sufficient for what we would need.
The other consideration is whether to get a dual version. They do some dual versions in case you wanted maybe a USB. I mean, we're talking about the breakout thing here. We're not talking about the modules anyway. So
have two
this is not convoluting the stamp, but for the breakout, for developers to get into it, would they want to have 2 sockets, one that they use to power and program and one possibly for doing data? I mean, that kind of depends on you developing a decent USB driver, of course, for
that would be pretty awesome for what you're talking about, doing industrial stuff, because on one hand you want this debug stuff to work, but at the same time you need to talk to it, and you can't do it over one channel. So having 2 channels would be convenient for a lot of things.
Oh yeah, UART. Yeah, I'm looking. Do they have any like dual UART ones?
They do. They call it the 4. It's the 4 range. So FT432, FT434.
Hey, is there? Oh, we would have to have a hub to connect up 2 chips, right? We can't just hook the DP and DM parallel to 2 separate chips and just call it good.
Well, you wouldn't do that anyway. You just connect 2 I/O pins together, surely.
Yeah, well, you'd need separate I/O pins to feed them, but
no, but what I mean, you wouldn't need USB connectivity in between. You just go directly P2 to P2.
Right, but I'm thinking about we were just talking about cases where you want to send data back to a host system, have a separate concurrent conversation with a host system.
Mm-hmm. Yeah, that's something else. I thought you were talking about having 2 propellers talking to each other.
No. Have another, because it's all virtualized over USB, right? If it's one USB connection, but 2 separate asynchronous serial ports, going to and from 2 different places.
Yeah, I think that's what Michael is talking about with the FT4 series.
Yeah.
So
okay.
Yeah. It's 2. You see 2 COM ports with the 1 USB connection.
Yeah.
You can't.
I mean, you could do it with 2 physical chips as well. It's essentially exactly that, as Ray says. It's just 2 channels.
But you would need a hub to arbitrate, right? I mean, USB devices can't really, I've forgotten, I kind of was getting into it for a while, but you can't just connect 2 USB devices in parallel on the same DP-DM pin pair, right? Because you need a hub.
They're not the same
They
pin. They're not the
can't,
same pin
no.
pair.
Because USB is designed by stupid people, where it's like where that would like almost work, but in reality it doesn't work because those 2 devices would get the same address.
Oh, that's right. So there need to be some like little hub between them to separate them.
Yeah, I think we're talking at mixed purposes here, but anyway.
But they do have the multi-UART. They have one with quad UART. Oh.
Yeah,
that's just multiple in one device.
Yeah, 2 would be nice though, because I do like using the debug, but I can't have the debug working at the same time as talking to the controller. So yeah, so that's a problem. So
well, that's
I
not
do like
really a problem. You can separate out the debug data.
Do you
I
know,
don't know.
if we wrote firmware to spoof the to spoof the FTDI chip, we could have any number of ports, could we not?
I mean, that's just the VCP stuff. Yeah, you can have, there's some amount of limit just based on how many descriptors you can have in a single device. But you can create infinite virtual COM ports, essentially.
Yeah, we could identify as several COM ports. But at full speed, we're kind of limited anyway with 12 megabaud signaling. Oh yeah, dual channel UART. That's that part's more than twice another part. It's $5.
Yeah, it might just be cheaper just to lay down 2 individual FT232s or 234 XDs, but
oh, and then just have separate USB cables going to them.
Yeah. Well, I mean, that was the whole point anyway. And so, you know, how we do it in hardware is kind of irrelevant because we'll just design it
yeah,
using
of course.
thing. But the
yeah,
point
we're gonna want
was
separate cables.
Yeah, the point was if there would be a purpose to have 2 separate USB ports, one that's used for power and programming of the device, and the other one that's connected to a couple of other USB pins. A couple of other pins on the P2 chip that can then be used for data. And that's what Ray was also talking about, that would be useful, you know, if you're developing applications that want to have a USB socket. Or USB
of course, we'd want 2 separate cables for that.
Yeah.
So
that's why I got confused with what you were saying. You wouldn't connect them.
My brain is a muddled mush of... I think I have deep resistance to USB, so I don't want to know about it.
Actually, now I think
Forget
about
the USB details. It's too horrible to remember.
I guess the cheaper option is to use a prop plug when you want to debug, and use I think debug will let you change the pins, the default pins for the uses for UART, and then switch those to unused pins and use a prop plug. That way, it's not a permanent thing. It's just for debugging. So that's probably a better way to do it.
It's actually a neat idea. I like that idea. It saves the cost of saves burdening everyone with the cost of that hardware, doesn't it?
I like that idea, and not having 2 pins tied to another USB port that you may not use.
Yeah. Yeah, that seems to be the solution, because then people that buy the thing can debug off the bat using the one cable, and people who, you know, want to get into it more seriously can add a prop plug in, and yeah, perfect.
But we do need a prop plug, we need the equivalent circuit just to facilitate easy startup, right? We have to have some FTDI chip.
Yeah, I mean, easy startup would be, USB-C FTDI chip to the programming pins. So you'd be able to power and program the thing off the bat, exactly, just with a USB cable.
On some of these FTDI chips, they say like single channel high-speed USB Type-C to multi-purpose, but UART, JTAG, a bunch of junk. Well, are they saying that the Type-C connector, because of its power delivery potential, needs some special electrical interface to negotiate?
It doesn't really, but it's good to have some sort of extra negotiation stuff.
Because those chips are like, you know, twice as expensive as the little ones.
I think you'd need to like connect one pins up in a special way or something. But other than that, it's just like a regular micro USB.
Well, I think this 234X is the deal. It's super tiny, it's not expensive, and each one we put on provides a UART. Unless I just missed the plot again.
No, that's pretty much it.
Also related to the LCD thing.
Oh, in fact,
Watch.
you know what?
It's happening again.
That what do you guys think of this? Since that part is so tiny, that 234X, okay, and it's cheap. It's the cheapest part they make. It's a 12-pin DFN. It's very tiny. It would actually fit on that little module. So would it behoove us just to go ahead and put the programming interface onto the module so that people wouldn't have to worry about some janky prop plug that's wandering around on 4 pins?
No, because you can't. We definitely don't want to have a USB connector on there. So it's irrelevant.
The USB connector is still on the baseboard that has the socket or whatever else you plug into it. But having,
No, I get it. Yeah.
I like that tiny part you have, I think would fit on the stamp module. You put on whatever you plug into your baseboard has the physical connector, but doesn't need the separate part.
Right. Well, yeah. My thinking was that because these parts are all surface mount and they're a pain, it would be good. Anything that's going to be requisite for just starting up and getting things going, if we could, without much adder, put that onto the little PLCC board, then it would just save the trouble for anybody having to. So Steven's saying no.
The trouble is, the thing is, the whole point about the stamp is it should have nothing on it so people can decide in their own application. This product is absolutely for system builders. It's not for developers. They might, we might make a development breakout board around it, like a.
Got it. Okay, I'm resolved. I understand now. Yes.
Yeah, and people.
Well, the other issue there is you want to have the equal trace lengths for the DP and DN, and I don't know what you're going to do. So that's just asking for trouble.
Oh yeah. Well, for full speed 12 megabaud, would it matter? I could see that for USB 3.0, but you're never going to have. I don't think that they ever gate those high-speed signals towards full-speed devices, right? Because it's known that would just not be a good idea. Is that right?
The hub just gates the hub pretty much just gates everything that you don't want. You might get something for devices that you don't want at your speed grade, but if you're a full speed device on a high speed hub, the hub will actually translate the incoming high speed data to full speed. If you're a low speed device on a full speed hub, there's something called a preamble that's needed to make sure that the low speed device actually gets the data.
Okay.
And there's actually a difference in USB 2 hubs, because some hubs only have one USB 2 to USB 1 converter, and some have multiple.
Oh, okay.
And so if you have the lower quality one, you can only run one USB 1 device at full tilt, and the other ones are getting starved if you're using it as a USB 1 hub, whereas with the multiple ones, all USB 1 devices run at full tilt. Sorry.
There's this funny little chip they make called the FT260. It says it's a UART that goes up to 12 megabaud, but it's an HID class. I mean, doesn't the HID class inhibit you from sending over like 800 bytes per second?
You can request larger packet sizes, but there are, restrictions.
What number was that again?
FT260S.
Yeah, I looked into those all those things not too long ago, and I decided to stick with 231X. But
It's much simpler. And it works with everyone's tools already, so it's not going to cause anyone's software pain either.
I have to leave
It
in a
says
second. but I
UART
just wanted
interface supporting 12 megabaud. I don't know what that means. It says it also supports HID if you. The I2C mode of operation will also support the HID over I2C protocol defined by Microsoft with Windows 8 or above. Okay, whatever that is. Let's check the datasheet. Maybe it will elucidate us.
Well, I like what I saw with your version of the P2 stamp there. So I hope you go through it. But I just want to say that the guy that designed it seemed like he really knew what he was doing. It probably has a lot more features than you need. So I like the idea of making it bare bones and copying the core from the edge. So that all looks really good.
Yeah, it's definitely a different product or different aim, just to have something absolutely bare bones rather than the stamp fully featured thing that Kiev, I think his name was, made.
Yeah, that has just everything in the kitchen sink on it.
Hyper RAM as well, as I recall.
Yeah, it's got the 16 megabytes of it. I mean, 16 megabytes is pretty fine still.
Yeah, I think you said keeping an RTC. That sounds like a good idea because I think I do like the idea of having a battery. Not a battery, but what's that thing called?
Super
yeah,
cap.
the super cap, the backed RTC. Yeah, that's I like that idea.
So you're thinking it would be good to put an RTC on the bare bones module?
Yes.
I do. I actually do too, because that's like RTC is important for a lot of stuff that's going to have a life in the world where it has to know the time of something.
And the knives guy, he also put in like all of these tiny little logic chips that like turns off. With external jumpers, you can turn off all those things. You can like turn off the RTC, you can turn off the hyper RAM.
So you
I don't know
unload
why you do
pins.
Yeah, but I'm not 100% on board with that idea, but that's what's there. So I like having a dedicated I2C port that for the RTC that would on the external board go to a quick connector. And yes, I know Parallax doesn't seem to be on board with the quick connector stuff, but I really like it because it makes like I've seen people in the forum have trouble getting their I2C to work, but when you have the quick connector, you stick it in there, you tell it the pins, and you're done. It'll work. That makes life a lot easier. And there's all kinds of stuff you can buy with the quick connectors on it these days, so from Adafruit and SparkFun, and other people have ones that are compatible with adapters.
So what's the consensus with the rest of you? You think an RTC would be okay to put on the module? So what we would do is we would have a pin coming off of the socket, which you would put the super cap or the battery on, but then and then we'd also bring those two USB pins, or what are they, I2C pins out in order to, not totally hide the pins, but there would be.
Wi-Fi 3, you can just do that, right?
Yeah.
As long as you don't connect another RTC with the same address.
Right.
I guess there's some problem when they get confused by like when the RTC only does like slow speed and you do fast speed. But like who does I2C's fast speed?
Well, yeah, I2C is all kind of low data rate stuff anyway, so inches of traces aren't going to hurt it. Michael, do you know what?
Actually,
go ahead.
There's I think there's a lot of new stuff that works at 1 megahertz.
Okay.
RTC. So, yeah, I would personally, I'd try to, if there was RTC that can do 1 megahertz, I'd do that so you can have high speed stuff, other high speed stuff on it. But I don't know. That's just me.
Do you know what the cost was, Michael, on that RTC we had spec'd out that one time? Was it like $2 or?
I can't remember, and it feels quite certain that we'd change it anyway if we did it again. There's bound to be
Okay,
something
so
smaller and cheaper now.
okay, so
Certainly,
N I squared C real-time clock. I'll go to Mauser really quick and just look.
yeah, while you're doing that, I'll pull up the bomb on the other one and see what it was. But bit of history, bit of nostalgia.
Well, I'm not. Yeah, I don't think it has to be on the chip. I mean, I would be all for keeping it bare bones and having it not be on there, but just
Yeah, I maybe it doesn't belong. I mean, it is a simple part. These things are like tiny pins, 8 pins oftentimes. They're $1 or less. Yeah,
If it
here's
doesn't
one.
need to be on the board, then I don't think you need to put it on the board. I think these
I
RTCs,
agree.
they even make them as dip chips. So you can just like plop one of those onto the board and it'll be fine.
Yeah,
You don't need
NXP
it on
makes
the
one.
module.
There's a 40-cent one from NXP that has like 8 pins and it's a little QFN, not QFN, probably DFN. So they're yeah, I agree. That doesn't need to be on the little module.
Yeah, you can
Just
make the bare
bumping up
bones
the
little
price too
module,
much.
and then you can make like, the sort of, or you can just take the Ray Allen board here, Ray's logic board, and just use that as like the standalone board.
Mm-hmm.
I think
Yeah.
that serves the market segments question mark well.
Yeah.
Well, maybe add like the mythical third bank of PS RAMs to make it the 96. Just for
Yes.
obvious reasons.
So all the thing really has is just no dip switches, no USD connector, just voltage regulation, clock source, and 16 megabyte flash, and that is it. Right?
Oh, yeah. The other thing you might want to copy
Logan
is
says yes.
the stamp uses like external. It uses some of the pins to decide the boot mode. So instead of like the dip switch approach, you use I use solder jumpers to decide how it's going to boot. But you could
If
use.
you bring out all the pins, then you could just put the pull-ups externally, right?
Yeah, you could add that onto the carrier board.
The carrier board could have dip switches to do the same thing. I use.
Yeah.
I use solder switches, but that is kind of a nice feature. So you can retain the dip switch kind of thing, the ability to choose your boot mode.
Mm-hmm. Yep.
Oh,
yeah. The external.
He has the other trick. I don't know if you want to do it or not, but he's got a USD connector that where it sits on top of the board and the USD actually goes over other chips. So that's kind of a neat feature.
Micro
That's how you
SD,
can,
micro SD.
Yeah, you get a micro SD that takes up basically no space and actually can the USD can go over other chips on the board. So
where did I put the thing? I can show that off again.
And now we're getting back to making it with a lot of extra stuff. So we're coming around and round and round. We're trying to have a simple P2 design that, companies like mine and John's and others can just drop in and it has the bare basics. If all the pins come out, I hadn't considered that. If all the pins come out, the P2 pins, then I guess you could do the thing with the external switches and all that. But I'd like to be able to put the module into a socket, not have to worry about it not booting up from the flash.
Yeah. Well, let's see. If we want to go serial or flash, we just put a pull up. Let's see, we turn the flash. I think it's just 110K pull up.
So I can reprogram it, but if there's no reprogramming, it'll boot.
Right.
Okay, good.
Yeah, the other
Demonstrate
advantage
the
to keep it.
SD socket thing. So this is the P2 stamp. This is the P2 stamp with an SD card in it. If I can do it one-handed, there we go. Now it has an SD card in it. This actually works, by the way. It just sort of fits. Like this doesn't even go outside of the footprint of that socket, and you get your 2 terabytes of memory or whatever you can put in there.
That's a neat trick. I guess the counter argument is to keeping it simple, because a lot of these parts they can get a lot of stock and you can't get them, and then you can't build a board. So having it bare bones kind of makes that part easier.
Yeah, that's the question. I mean, this costs this is like no extra circuit. It's just the connector, I think. But yeah, you have to weigh that.
That's the thing about this thing, is that when you take the SD card out, it's basically not affecting your circuit at all. So it's yeah. So that's a design. So it's a design.
That's got to have parts on the bottom too, right?
I think it has, but I'm not gonna take it
It
out of that
does.
socket.
It has the bypass caps on the bottom.
Yeah.
Yeah, so
well, we could do this.
So you can't solder that one to a board like you were suggesting, Chip. I don't know that I would do it, but there are a lot of people making castellated boards now, and you know then apparently they can be reflowed. I'm building a cosplay controller for one of my friends, and we're using one of these little RP 2040 modules that's on a castellated board, and they said, yeah, you can reflow that, go to town.
Yeah, you can if you cut out, you'd have to, we talked about this on the forum before, but if for the stamp, and this sounds like it's similar to that, you need to cut out a square,
Yeah,
and then you can drop the board in.
So it'd probably be helpful for ventilation too.
Yeah, because you don't want, that thing's going to have to dissipate heat, and you don't want to have just a little air gap to some other more FR4. You'd want to have like a big open airspace. So underneath the socket, I would just cut a big open hole.
I must again mention that the P2 stamp I have runs like comically hot. Like it's actually painful to touch it.
Yeah.
But it never crashes. It somehow makes it happen.
Oh no, the
on
socket.
The other hand,
oh, go ahead. Sorry.
If you're actually doing an industrial application, though, you're not going to be at like 340 megahertz. I mean, you're probably going to in the 200.
200 is what I run. And
never. Yeah. So, and it doesn't get down there.
No.
So.
No. Yeah. Not at all.
You know, you might be able to take those. You might be able to get rid of a lot of heat over the pins. But the socket's gonna present some plastic surface underneath the module, right? So we can put all the parts on the top side. That we got plenty of room for that. Nothing on the bottom. But yeah, the heat dissipation on this thing would kind of.
I got the stamp running inside of a plastic enclosure. It's pretty much completely enclosed by plastic, and it's run at 300 megahertz, and it's just fine. There's no noticeable heat. So
okay.
I mean, I think it's like when you get above 300 that you start having heat issues. So and at least from my experience.
Yeah, this heat dissipation would be the issue with this thing. We could almost build it upside down and then have like a little heat sink that sticks to the bottom of the board, you know? So if we could get small enough inductors, we could just plug the thing into the socket upside down and have a heat sink facing up.
Well, the stamp is an 8-layer board, and it's got heavy plating on the edges, and it's got connected a lot of pin, 84, I suppose, things on it. So it's got pretty good heat conduction to the carrier board.
Okay, so it gets the heat out over the pins.
Well, I mean, different things, but there's no convection that doesn't. I mean, I don't have any fan in there, and it seems fine. Yeah. So if you're doing like 340 megahertz, you got different issues. You have serious issues to deal with. But at like 200 to 300, I think I wouldn't worry about heat necessarily.
Okay. What are your thoughts on that, Michael? I kind of think this thing would get kind of warm. It's like 2 a.m. for you, isn't it?
Us Europeans are about 1 a.m. I think. Yeah.
Sorry, you gotta.
It wouldn't. We haven't had heat issues on any of these modules running, 200 megahertz or less, and even faster. So yeah, I think what somebody just said, maybe that was Ray. It just it's not an issue. It's not an issue. And we're going to make the thing multi-layer with a big slug of copper on it, and do everything we need to make it
how many layers
as possible. But the other thing as well to bear in mind is I would put some sort of standard mount facility on any sort of breakout board that we supply as a demo, just to give people an idea that they might copy in their products. Whether it's just 4 holes placed at the right pitch or whatever it might be, to allow people to bolt a standard size fan or heatsink on the top of the thing anyway, like you would do in a computer motherboard, or at least an old style one, where you might have holes ready that you could put a standard fan on or something like that. Because then you just need a little bit of air movement to if you want to run super fast, and then it lets people do that. And as I say, it's more to give them an idea to what they might do in their own products, because that's where in the embedded environment they're going to have those issues. It's in a case. And after testing, we might decide that we want to recommend that anyway. So yeah.
Simple. That's what I do with the platform board. I only got 2 holes on there, but that's enough to hold the fan. And that does help a lot. But you guys with those 8 layers though, that seems to like suck away the heat. I don't think you even need a fan. But how many layers you need for this industrial board is kind of an interesting thing, because like I didn't design the stamp thing, but they picked 8 layers, and I think when you have all these extra things on there, like the RAM and stuff, I think you need all those layers. But do you actually need all those layers if it's simple? I don't know. That's a good question.
I think 4 would be fine. Michael, what's this thing? How many layers is this?
I think I can't remember. It's 6 or 8.
Oh, it could be 8. I thought it was 6. I think for this little thing we're talking about, though, 4 layers would probably be sufficient, because we're just escaping the pins right out to the, where's my camera? Right out to the edges of the socket anyway. So there's not like a lot of routing in the middle of the thing. Well, there's nothing because there's a chip there.
I bet it ends up being 6 layers.
Yeah, maybe so. I'm trying to still get a lock on like how big is, when you have something that drops into a PLCC 84-pin socket, what's the dimension of that? Like
27. I think it's, from memory, I think it's 27 by 27. The PCB.
Oh, that's over an inch. So it's like, oh yeah, well, 27 millimeters. I have my measuring tape here from Home Depot. Yeah, we would, it would be kind of, but that other guy's board, he had the P2 tucked over in the corner. I'm saying if we're like an inch, 25.4 millimeters, we don't have much room around the chip at all.
Somebody showed me, was it Von Savras? Michael, that was showing an image when I joined. I saw an image of a square thing that said industrial P2 industrial on it. Was that the size? Was that the size?
No, that wasn't to fit in the PLC 84 socket, right?
That
Mike?
was I think that was to the size of the. It was close. It was close to scale.
Okay. Yeah.
Actually, I feel like I wanted to say yes, it was the size, but I'm just double checking quickly to make sure I measured it right.
Okay,
So I feel like it was the right size. I'm just quickly measuring.
I'm seeing 29.26 square, but that's probably not including the pins, right?
Yeah, so that was the right size, but it was out. As I drew it, there was a plane there, so it was hiding the pins or the castellations. So, yeah, so what I drew there would fit. If that's
Michael, are you using Altium by any chance?
No.
Okay, because that makes things easier for you if you could just use the P2 stamp footprint. Yeah, or maybe you can somehow import it, but he's open sourced the design, so you can. I don't know
if you shared the Gerbers, use that.
But he also shared the Altium design files. At least I have it. And I think you posted it for everybody, but yeah. But I have it if that helps, the Altium. But it is getting the.
Yeah, I mean, it's worth having a look at if you don't mind zapping it over, because if you just send it to support@parallax.com, that would be fantastic. But I think he, as you say, I think he shared the at least he shared the Gerbers, which I could also use to import the outline.
Yeah. So from the Altium source, I downloaded the test the freeware version or the demo version of Altium, and I was able to export and able to get the outline into Eagle. So theoretically, I could design another board, and I was gonna kind of do what you guys are. This is great news for me, because I was thinking about doing what you guys are thinking about doing, is making a simpler version with none of the extra stuff. I think so. I'm totally happy to see that. And I wasn't a big fan of this PLC socket stuff before, but it's growing on me. I'm starting to like it now.
That's how I feel. That's my attitude too. I'm not in love with it, but okay, it's viable and it'll work and it'll get our signals out. And the socket's not too much. The socket's about as low additional footprint as you can get if you want to have it separate from whatever's on the main board.
Yeah, and getting it with this socket, I'm able to get PCBs inside of the these PLC style plastic cases, and very small ones. So it's very so if you to me a P2 PLC is like very real. I essentially have one now, so it's it's kind of I think that it could be I'm not a marketing person, but it seems like it could be a product for you guys. So
yeah, I think it solves the problem of making it easier to start with lower cost and definitely smaller footprint than an edge. Yeah, we got enough room to do that.
Sorry, I just crashed the share, but while people were talking, I measured the P2 eval board and stuck the socket on there. So it'd be nice and clean. USB comes in over here. Technically, if you know, the other stuff could be there where it is now and the power there, but it would make a nice tidy board that this whole thing plus the industrial thing could be sold as a, you know, starter kit. And then it's compatible with everything you guys have already made. And
Yeah.
that Ray's made and I've made and other people have made. Yeah, Steven Morocco makes accessories too. And this would probably be a 2-layer board, right, Michael? Or am I being silly?
Yeah, that would be 2-layer. Keep the price
so
down.
this becomes very inexpensive.
I mean, you could probably even do it as 1-layer, but I'm not sure if that's really an advantage
Oh,
anymore.
no.
No way.
Probably not.
Yeah, because we got to put the USB chip on there.
Yeah.
And also the PLC socket will be through hole, so
Yes. Yes.
Yeah, I don't think
Well-
I've shared it on the forum,
Would it?
but one thing that I'm doing with these things in that plastic cases, I think I described it, that these little plastic cases that are meant for like industrial control stuff. These butt enclosures, butted plastic enclosures. So I made the carrier board. This is maybe an idea that you guys could run with too. I made the carrier board that fits in there. It has 3 of those edge style headers on it, so that and so you can stick it'll fit inside the plastic case, but you can also connect like the standard parallax accessories to the headers for like initial testing if you wanted to. But internally, what it does inside the case, it uses those headers to connect to other boards vertically. But for like initial testing, you could also connect the standard parallax accessories to those headers. If you know, it's just an idea there. So, and you know, in terms of, I don't know if you were really discussing industrial stuff, but if you were, I really like the there's a thread about P2 PLC and these RJ45 connectors for like 4 P2 pins plus 5-volt power. That's really convenient, I'm finding. I like that idea. And yeah, so anyway, so I'd be very happy to see that you create this board. So I just want to give you some positive encouragement.
Thanks. Yeah, I think it'd be good. We need to lower the barrier to entry in terms of cost and complexity. And I think this is kind of what we need to be doing. It would get people close to realizing whatever application they had in mind without a lot of detouring and reinvention.
Yeah, I mean, for me though, so you take this, you stick it in a board, it fits onto a DIN rail, and it's a controller, and you can program and spin if you want. You can do it in C if you want. You can do it in the PLC languages if you want. I think it's really a very powerful solution. So.
Yeah. All right. Well, Michael's on the phone, but we know what to do then. All right. Well, maybe next time we meet, we'll have this thing designed.
Yeah, I mean, because when you look at like doing industrial control, having these 8 cores, that's where it can really help you. I mean, because you have the one you want to do your core cycle, like a PLC cycle in a fixed time, do limited things to make sure it can do everything it needs to do on time. At the same time, you'd like it to do other things. Like one cog could like be updating the display somewhere. One cog could be taking input from serial devices, for instance. One cog could be like doing a data recording thing. So it's very useful.
Yeah.
It's hard to say, but as Ray was saying, Chip, and first, thank you for considering this. I know I've been bludgeoning you with this request for a long time, but As
No,
you can
I
see,
appreciate it.
in context, it will help us with our products. Josh was busy, so he wasn't able to sit in and hear this. I get him to call him and say, "Hey, this could be good for us. It'll certainly help us. I feel quite certain it'll help John because I've helped him with his products. And as Ray was just saying, that's I think an opportunity for Parallax, and people like Ray are demonstrating that in the PLC world. That industrial controller, I think Michael's term for that module, P2 industrial, is a really good marketing move. And it helps with that. And with that, and with a standardized socket, I mean, to give an example, I was, ordering parts so I could build that, the board I showed you, the one with the vertical socket. And I can't get that socket from DigiKey. Now, it's fine, I ordered them from you guys, but when we send that to a contract manufacturer, it just complicates things if I can't give them a bill of materials that says, here,
Right.
you can get them from a single source. So
Yep.
this will help because a PLCC socket is 50 cents.
Yep.
So again, I sincerely appreciate you considering this and having the discussion, and I think it will pay off. I know it will be good for our company, and I think that means it'll be good for you too.
Yeah, well, we need to get more customers going, so whatever can help that to happen is welcomed.
It'll certainly simplify. I mean, as Ada pointed out, yes, I could, struggle and lay out a raw P2 circuit myself on our board.
It's such a
This will
pain.
just save me so much energy.
Yeah, no, the P2 is a lot bigger bite
Yes.
to chew than the P1 was because of thermal stuff and bypass and voltage regulation.
Yeah.
It's not, and it's just that's fine pitch, it's a pain to work with. So we need to solve that problem and then let the customer deal with something simpler. Let's see. I'm looking here. Oh, here's some sockets at DigiKey. Yeah, they're like $1.58 for the socket. And they're saying they're both obsolete and they only have like a couple hundred in stock.
There's all kinds of companies that are selling them. Because like I said, I literally found them for 50 cents.
Yeah.
Although anything that is at or under the current, edge socket is fine.
Yeah.
But anyway, I've got to get back to work. Thank you, everybody. Have a great night.
Okay, thank you, John.
Thank you, John. I'm gonna echo his. I'm come to terms with the edge, but yeah, simpler, smaller. I'd be all into that too. The real-time clock, at least, yeah, whether it's on there or not, but powered off the side, be good. For industrial, I started that PLC thread, and I'm using I'm collecting a lot of serial on one cog. Got a console on another where I'm starting and stopping tests right now to collect data, things on the bench. And the real-time clock was key for data logging. And yeah, there's a lot of real-time importance in PLC. But then otherwise, the flexibility, not binding up the pins to certain tasks is just, that's, you look at all the PLC vendors now, and there's, it's hard to get the I/O you're looking for. You always need one more. I've got to buy another whole module to get one more ADC or one more relay. You've got to buy it's the hot dogs and hot dog buns thing. You never
Oh yeah, 10 versus 8.
the right match. But if you can, with some common connector, yeah, I've been using this on the bench lately. And in software, setting up the smart pins and setting up ports of 2 pins and ports of 4 pins, and leaving the physical connector the same, but being able to switch what's behind it has been pretty useful.
All right, well, good. This was a super productive talk. Thanks all of you guys for your engagement on all this. Should we wrap it up since Michael's got to go to bed? I think there's something I got to do before it gets dark outside.